there are maybe most of the time. I've got something in my screen. Sorry. There are about 15 or 20 people here, and there are some very active programmers, and most of them are not all that active, but a few very active ones, maybe 5 or 6. Willem is the most active one, Willem Ouwerkerk, and he's he's here behind me. And yes, he's always busy with no force and the Egel project to push no force and force, of course, for the world. But I'm not sure how many people are looking over there. A new project is embedded force, also of Willem force, and of your Ulrich. And that looks very good, but it has to grow a lot, and yeah, still in the initial phase. I like the idea very much, and I would like it if people come with ideas for programs or algorithms for the embedded force side. Yeah, this club is from about 1978. We're here for a long time. It was much bigger. I believe there were 800 members or more in the past. And we are not very young, I'm afraid. The youngest member is 33. It's 53. Oh, it's a bit older than I thought. So we are really rather old guys. A lot of them have got a pension already. Most of them probably. Yeah. So there's really time to start getting young people here, but I'm not sure how. Maybe with Lego or something. But maybe someone of you has got any idea. I would like to know if there are clubs with young people still around. Peter Forst, do you know anything about that? Or Ulrich, maybe?
Well, what we did in the Force 2020 group was promoting the ESP32 Force, which is very easy to install because it's in Arduino, and we can contact the makers. In the moment, I think the maker groups are the most important target for Force. Because there are millions of people, and if we get only a small part of them, we will grow without limits for our small community. And yes, and Wi-Fi with ESP32 Force or other Force which have Wi-Fi allow you to work with smartphones, and young people want to automatize their homes. They want to make things with smartphones or with tablets. So I think this is interesting for us.
That's very good.
To save you,
and there's also something happening on the internet, I believe, with Force.
Yeah, the situation that I'm facing is that well, my students they have a huge amount of choices how they can accomplish their things, and they are choosing the solution that is, at least at first sight, the most convenient and easiest for them. And so if there is a very elaborated, maybe very complicated development environment that assists them in a lot of beginners things, then they would go for it, which means they don't use the Arduino IDE, which is syntax coloring editor with push button control of the compiler and the Flash downloader. They don't use this anymore. Because they say, no, this gives us much too less help and guidelines. We want Visual Studio Code with plugins that know about all the libraries, and we can click on one on one function, and then it displays the online help. And then there's a button, ask a question on Stack Overflow just beside that, and they are familiar with these kinds of comfort, and they are looking for it.
That's
We all-
copy-paste programmers.
So yeah, we all know that in the end, it will be very difficult if things don't work out as expected. So if things get hard, it will be hard anyways. But as a beginner, they just look and say, okay, what is the most convenient thing for me? And then they go for these more complicated things. And then the question is, yes, if we sit side by side to a person like that, we can explain things and we can show things, and that this gets some excitement. But if they just look at it and they try to install something that is cumbersome to install and gives you already some difficulties, then they would just say, okay, no, that's not convenient. Here's a system, I just press a button, it's installed, and then I can start and I get a community that helps me and so on. And so that's our challenge.
We have to get these people to want to do more interesting, more difficult things. They're probably there. They can't all be that simple.
Tu parles, lui, je comprends rien. Là, c'est un allemand, je comprends un peu mieux.
Is
The
that
thing
right?
is that I don't think that making the user install an IDE and all that is what we call easy. If anything, from my personal experience, working with IDEs is big,
Trevis.
complex, slow, a pain, and all that. Whereas with, let's say, Zepto-Forth, simply, if you was starting with a pre-created binary, all one needs is a serial terminal, nothing more. And if one wants to go in and create new binaries, for instance, from my new RP2040 port, all one needs is Python and the ARM tool set for Cortex-M, which is not much, which is very easy to install under at least Debian, and no messing around with IDEs or whatnot. Oh, GNU-Make, you need GNU-Make for that too, but again, that's not much to ask for on any modern Unix system
64
have
participants.
Unix in the first place.
Yeah, I think we have a perception that IDEs are complicated, and that's probably why we use Forth. But the perception of the students is way different.
Non, j'ai coupé la
And
vidéo.
so maybe they will learn over time that an IDE does not solve the problems if they become really serious problems. But as a starting point, I think their position is really valid. Yeah, you can try some things that the Raspberry Pi Foundation are actually offering, like in the chat, there's a Raspberry Pi Pico installation. It's drag and drop with if you use Python, and then you can use the USB port as a serial line to communicate with the Python programs there. And if you, of course, we have Matrix Force on it, but you need a USB serial adapter to get the auto interpreter, and yeah, that's an additional step you have to do. And my experience is that the students then just say, okay, why is it more complicated than the other thing?
Well,
So-
with RP2040, that does have the, I've heard it mocked at times, but the feature that could use the file system device functionality for uploading UF2 files, which with the RP2040 port of Zepto-Forth, I've got a Python script that produces the UF2 files out of the box. All one needs to do
Travis,
is
please,
take and
one
boom,
moment.
that UF2 file.
Travis, please, one moment. This moment you are using for promoting the Dutch Fig channel, and I would like to hear them. So we go later to the fourth cafe and we make free chat. Okay.
Okay.
Leo, I have one question. Can you show the group again the robot of Ulrich working, because nobody was there when you showed them moving?
Of Willem, our character.
Of Willem.
I'll get Willem. Willem, we'll do it again. Willem is coming up. Willem, hier zit je robot aan het werk.
Bij deze.
En dan moeten we... En waar is Dick nou?
Dick.
Hoe kan je nou overschakelen op het andere ding?
Moet ik draaien?
Dat ding omdraaien, ja.
Oké.
Hele doos.
Nou,
Maar dan zien we het nu?
nee.
Ja, maar
de andere camera.
video aanschakelen natuurlijk.
Moment, I need someone.
Die heeft hier alles. Dick, just a moment.
Ulrich, you missed that part. It was fantastic showing the robot working.
Ja.
Ik zit even goed dat hij dat ding kan.
Ja, je moet even kijken.
I see Albert is also in the meeting there. Albert van der Horst.
Wacht even. Waar
Is
is
that
die?
technical person, Dick?
Albert,
Hallo.
hello.
I'm changing the camera now. And now you see Willem.
Ah, il y a une démo.
And I
Une fois
can
avec un
also I
robot.
can zoom out a bit. Maybe that's.
Wil je
wacht
lager?
even.
Yes.
Hij is wel goed, maar ik kan.
Maybe.
Moet je scherp stellen.
Ja, oké. Ja, is goed. Goed.
Zo?
Ja, iets verder weg. Hè?
Iets verder weg nog?
Oh nee, dichterbij.
Oh, dichterbij. Wacht even hoor.
Just a moment.
En dan
Ja, nou staat hij er meer hoor.
en ietsje meer. Oké, maar moet even opletten dat het niet van de tafel springt. Ik kan even op ziek.
Oh ja, hou maar even tegen.
Ja, nou, als hij soms.
Knopje drukt alleen maar.
Een knopje?
Daar.
Nee, gewoon verlangt lopen.
You were explaining this has many microprocessors and all are controlled by force or
Yes. It's going to function. It's a. There's in it is a very small microprocessor, an old 8051 microprocessor with flash memory, and it's programmed in only 4K of flash memory.
What does it do?
8051, c'est nul ces processeurs Intel.
It was using it's using byteford. Program written in byteford with Albert's Philly plop algorithm in it, and on a servo driver on interrupt basis.
well, I will put this video in the Force 2020 channel and I will share this with a lot of makers, and then you will see how many people we get into Force, and probably we get more people from the Netherlands, young people, because this is the way, Leon, if you want to attract young people.
They are not very young.
No, that's for sure.
Well,
Gaffe, les
everybody
vieux
will get older
Maybe-
one day.
Maybe in our minds,
les
but
jeunes, ça peut être mal pris. Hein.
Même dans le milieu informatique.
nee, want ik zie alleen maar een voedingsding hier aankomen. Nou, je gaat nu weer.
Ah, est-ce que c'est Jos?
You can see him react.
Non, c'est pas Jocelyn, mais il ressemble.
Ietsje uitzoomen.
Il a fait un gros caca.
In this robot, there are about 8 courting dances of birds programmed.
Après, elle serait bien allée jouer avec Pike, mais son maître était en train de tailler.
I could not understand that, sorry. But Yes, it's one of the examples. It's an object I made about 15 years ago, and it's nice that it's still functioning. It's all from all old servo motors and parts from broken printers. All scrap.
C'est le servomoteur d'une imprimante.
Leon is showing an updated version. Used
3D
made
printer.
using 3D printing. It gets a lot more movement possibilities in the future.
Kijk, er is ook twee ervaring van.
Yes, that was the original example.
Vertel wat het is.
Can the code be reused for other robot arms?
And now it's aggressive.
We also wanted to make it work with two robots.
Nu wordt een oude. Nou, kijk.
In my opinion, the force community or Dutch force community can use the actual media we have. For example, make an instructable. There is a web page, instructables.
Yes, instructable, I know it, yes.
Put this robot and show the world. We do this with small code. This is the importance of force.
Okay,
Peut-être, hein, mais pas.
it's a nice idea. Maybe we should do that with all of our robots, for example,
Exactly.
and show the fourth code that supports it. That should be nice. And
Oui, m'impressionne pas.
to prove that Ford isn't just an old obscure language.
Ah non, si j'ai oublié de le fermer.
D'accord. Par contre, je peux la laisser sortir. Hein.
Ah oui, si elle a envie, elle peut.
How many robots do you have?
I don't know, I think about 10, 20.
Oh, and what do they do?
I make them as art objects. So I do expositions and
Okay.
sometimes I do openings of a conference or something like that. But mainly for myself. I like to build moving and lightning things. Sometimes I build objects for other artists to report also.
J'adore ma compagne.
You've got één of twee in.
Yeah.
You've got
Have you done anything in animatronics?
What was the question?
Have you done anything with kind of animatronics, like making
Oh,
creatures?
no. It's all plain Ford. And I use Albert's Pili-Plop algorithm for it. And that's a Brazenham-like algorithm.
Yeah, I think Don's question was, do you use animated characters like humans or puppets or something like this?
No.
Now we've got a kind of puppet in the Eagle project. He made a kind of puppet.
Yes, I like to keep them as technical as possible and try to bring behavior in it, and the behavior makes it alive. So I use my own behavior, for example, in one of the robots.
Bad behavior.
Bad behavior, yes, and behavior of a person who locks himself up for many hours and builds strange things and find it difficult to communicate with others.
A geek.
in this time. Yes, a geek.
Can you show us some other robots you have?
That I didn't understand.
I was interested in seeing some of your other robots. You said you had 10 or 20 of them.
I don't have other robots with me for now, but I can show you one other time. I can maybe next time for the international group, I get a small presentation of them. We are now in Beeldhoven, and I only got a small case with some things to show what embedding forth the project I do with Ulrich to do for us. And the Pili-Plop algorithm and SPI is an example used in these robots, sometimes together. And I hope then we can make it possible to share lots of code. So it's easier for all of us to make nice or nasty things. Any other question? And Ulrich, can you add something about embedding forth?
Yeah, sure. Yeah, so the idea is we all want to make force more popular, of course, and so there is a long-running standard effort to make common things and build up a basis for communication or for portability. Started with American National Standard and continued in force 2000x standard effort, and so that's one approach, and we see that this is quite slow. There are proponents that actually think that's a good way to do that, but Will Baden once said his daughter told him, "Daddy, if you've seen 1/4, you've seen 1/4." And so that's what we observe as well. Force systems are very different in their structure and their capabilities. And still, as a community, we want to share ideas and things. And so the standard tries to make systems alike, and so that you can port programs from one standard system to another. And so we said, okay, but if we tried for 30 years to do this, and we still see lots of different force systems, which I believe is a very good movement and very interesting, and puts us apart from other language communities where they have just one implementation and that's it. How can we deal with this situation? How can we benefit from each other and actually build up community and help each other? And so the idea that we had Willem and I and Martin Bitter is that why don't we just embrace the difference and say, okay, yeah, we have systems that are different, and why don't we share ideas? And I think this is, as I understand, also how Charles Moore, and we will learn about this maybe, used the early force. He didn't carry it over force programs, but he had his ideas in mind. And once there was a new task, then he reused the ideas. And that's the approach that we want to use with embedding force, presenting ideas and explain, especially to newcomers, but also to professionals, how things work, what the underlying essential idea behind a certain issue is or a certain problem is, and then present on a very abstract level with pseudocode and also with something that we call minimal force that Peter Nex has proposed, and Paul Bennett at some Euroforce conference. Very simple implementation, so you get the idea, and then if you're satisfied with that, you can take your own force system and implement it as you like. And in addition, we provide implementations for the many different concrete force systems, but we can't do this on our own. So at the point where the idea is clear and the pseudocode is clear and the minimal force implementation is there, then everyone is asked for to provide implementation for his own special force system with its capabilities, to show that he can do this in your system, in his system as well, and others that use that system can benefit from that. So we ourselves provide implementation in no force and also in make-crisp force, because that's the system that we use for embedded programming. And ESP32 force would be, of course, an option to do that. But everyone is, in principle, invited to participate in that and provide additional implementation for the ideas, or even come up with own issues and describe in the scheme that we thought of, describe an idea and a solution in, as I said, in pseudocode and then in minimal force. To contribute, and over time we hope we can build up a different kind of library. So it's not a library that you can link into your program, but it's a collection of ideas. And if you have an issue, then you can look at embedding force library and see, is there someone who already dealt with this idea or with this issue, and then you can learn about that. So it's both a lexicon, an encyclopedia, and a library at the same time. And if you're lucky and you use a system that many others use as well, then you can just pick an implementation. And of course, we know you wouldn't take the implementation and load it in your system and make it run. No, you would look at it, want to tweak with it, make it better to suit to your style. And then you're free to contribute that perfection of the source code. So that's mainly the idea. And probably Willem and I and Martin will give, and Jos will give some more in-depth presentation in one of the future meetings. We had the summer break in some way, and we're just getting on track and wanted to prepare a lot of things to show, so that it's not just an idea, but something that you can see, and then you can decide or whether or not you want to follow or contribute to our project. Did I summarize this well, Willem?
Yes, thank you, Ulrich. It was very well said.
Okay, yeah. So that's the idea. Yeah,
I'm
Willem.
satisfied with that, and I hope there will be many contributions from everybody.
Yeah.
Ulrich, I will propose. I have an idea.
Mm-hmm.
This is first of all, I want to say welcome in the group to Chuck Moore, the inventor of force. An applause.
Yeah.
And then I was thinking, because I received many feedbacks during the week, how we should proceed with this special meeting. We have a schedule. We showed this a couple of minutes before, but I was thinking, since our main interest is to chat with Chuck, why not start now a free chat, and then we follow, if there is time, with Ashley Faniello and Peter Jakaki, who will present. But I am saying this, if you agree with me, please tell me, because Dutch Fig had a meeting today and they want to leave probably, and Australian friends want to sleep. This is why I say that. Do you agree? Or good plan? Okay. What do you think, Ulrich?
I think that's reasonable. Let's do it.
It's not that we want to sleep. We just need to sleep sometimes, but you know, that's good.
It's okay, Peter, with you. Okay, fantastic. Then why don't use the opportunity to begin make a question. Here's Chuck Moore with us, and also Dutch Fig, please follow you with questions to Chuck, or with the chat, with the free chat.
Okay.
We want to sleep.
Who is going to start?
You.
Okay. We have written some questions for him.
Oké, ik ga je. Kijken.
Yes. My first question is, we don't see Chuck much online, and I'm very interested in what he's doing now, and is he still working on and with Ford?
Yes, of course. Can you hear me?
Yes.
Yes.
Okay. I have a wonderful version of Colorforth, which I use almost every day. I'm not doing anything impressive with it, just messing around with computers. Basically, I'm retired. I spend a lot of time exercising, trying to stay alive, making food. It's a very pleasant life. And I certainly don't want to be under any kind of pressure to produce things. So I'm basically not. I have a number of applications in Colorforth that I enjoy. They are emphatically not portable. Forth, to me, I agree with Ulrich, is a personal language, and I'm doing it my way. And I would be happy to share ideas, but no one would be interested in my Forth code.
I'm not so sure.
I think we're all interested in everyone's ideas, and especially in yours.
I would love to see it.
Sometime maybe I can show it to you, but I'm not set up to do that now.
And on what computer are you doing it at the moment?
Sorry?
Are you doing it on a GA 144 or another computer? A special computer, maybe?
No, it's on a PC.
Oh, normal PC. Okay.
I've got a 4K display, and it's all tuned to 4K.
Okay.
Although I have it parameterized, so I could display it on 2K, it doesn't work very well.
That means it's small screen? 4K?
Large screen, 55-inch.
55, big screen. Okay.
55-inch 4K display. It's a TCL television.
Okay, very
And
nice.
it works just fine.
And you only do Forth on it? Or also other things?
I browse the web and YouTube.
Okay.
But, that is my Forth display.
It's very nice to meet you.
Thank you.
We have got an old club here from 1979 about.
Okay.
We are rather active still with few members, maybe 30 members are active. And more than 100 members are there, but not here normally. And we are all very happy to use Forth because it's very flexible and it's very basic. You can do very smart things with a little bit of code. It's always been my favorite language. So
I'm impressed.
I'm very happy that I invented it.
I'm impressed with how many people are interested. I gave up long ago trying to promote Forth.
Yes.
It's a hard sell, and I would just rather use it myself.
Yeah, I can understand that. It's really a hard sell. You can write beautiful code with it, but most people only do stack manipulations, I believe, and that doesn't help.
beautiful code is right. It's back in the old days, I thought that people would write their own programs, and that Forth would be a great vehicle for doing that. And it would appear that 1,000 people out of 8 billion are willing to write their own programs.
Yes, most of the people like to copy and paste only, I believe.
Well, even worse than that, they just use whatever application is given them.
Yes. So they're not
Leon, I agree to what you are saying, but I think we in the Forth community, we love so much Forth, and we love so much the work that Chuck did with this language. Now it's our turn to promote it. We have chances with Forth because Forth is an intelligent language, and people who want to program and learn is fantastic. So I think we should promote this for the young generations. Not giving up. Don't give up. Keep promoting.
Yes, you're right. I believe it might still have a future for us.
It might.
Because it's small and it's flexible. If you have only got, if it's very expensive to write this code, if space is very expensive, it's important that you have flexible language like this. You have also got this this nano programming thing that they try to write programs in molecules really. Maybe Forth is very good for that. Might be nice.
If I can offer, can I offer my opinion in this now that I've turned my microphone on? I would, from my viewpoint, although the Forth community is relatively small, and occasionally I look on the TOB index to see how small, how far down Forth programming is. From my perspective, Forth has, I guess, two major characteristics that mean that it will be a language that survives and may see better fortunes in the future. And the first is that Forth is a first-class language. So the ability to be able to sort of design things that are as deep as any possible language that has ever been created is a real strength of Forth. You know that you can extend the compiler to make it do other things, and you can introduce new concepts with Forth at the deepest possible level that any programming language could do. In fact, much deeper than pretty much any programming language around. So that's one of its main strengths. Can you hear me? And secondly, I think its biggest strength is that, its second biggest strength is that versions of Forth can be created, modified, and maintained by a single person. And so, although today we see an awful lot of languages that are sort of proliferating, everything from sort of scripting type languages, web languages like Ruby, or modern sort of supposed embedded languages like Rust, then Forth has the ability to be created by a single person. You can actually write the whole compiler yourself, or a new version of the compiler, and therefore, you know, it can survive if at least one person knows how to develop with it and at least understands it to some degree. So I think it's those two basic characteristics of the language design mean that it's going to be a survivor in the long term. Sorry, I'm Julian Skidmore. I created the Fignition, by the way.
This is the creator of Ignition, Julian. I am very happy to see you in the group. Fantastic talk.
So I finally joined the Zoom meeting because I didn't really know much
So
about it.
this is wonderful because Julian created a force in a very small chip in a very small environment. So he talks with much knowledge. What he's saying is very important.
Oh, thank you, Peter.
I'd like to make a comment. This is Don Golding. I think the future of Forth is very bright. Think about in terms of your brain. Do you have to recompile your entire brain when you learn something new, like you do in C? Or do you incrementally learn something? If you're going to have AI computers that are intelligent, they have to be able to incrementally compile. They have to be interactive. Is C interactive? No, you have to write an interpreter. Forth is naturally interactive. So I think Forth is an incredible foundation for AI. And I think that is really the future that's going to really explode over the next few years. My background.
Yeah, I believe you are right about the AI thing, but I'm afraid most people would like to use Lisp for a thing like that. It's a bit high level. AI.
Well, Dimitri, who's my partner in developing, we're writing, creating Forth on System Verilog for FPGAs, and Dimitri just got it working the other day, where we're executing, microcode in the machine and blinking an LED using if-then, statements. It's basically O branch. It's implemented in 2,700 lookup tables. It can fit on a $5 FPGA. You could put 100 of these processors in a $300 FPGA. Dimitri also implemented Prolog written in Forth that we're going to put inside. We haven't decided whether we're going to use microcode, in other words, write it in Forth in the ROM, or write them in System Verilog. System Verilog is the assembler of this machine. So you can choose either to code it in Forth, or you could write certain words you want to run the speed of silicon in System Verilog.
Also use Prolog if you like. That sounds very good.
I'll make a comment on that. Am I? Yes, I am audible. Yes, I thought about languages and what kind of things we might want on top to reason about things and represent knowledge. And I was inspired by the paper by Lou Odette, one of the older Forth programmers who implemented Prolog in Forth. And the reason I ignored Lisp is because I think that for the most part, Forth does about the same things, and it does them better. It uses space more efficiently. The only thing I thought that was lacking was symbolic processing. So I was looking for something that could be on top, a layer on top that would allow the processing of symbols, because I was thinking that that might be a sort of next step in computing more than just number crunching, because, and I believe Chuck mentioned this at one point as well, we don't really use computers so much for calculations, for calculating things as before. We're mostly moving memory around, but symbolic manipulations can be very powerful. For example, you can easily implement something like calculus in just a few lines of code, because it can manipulate symbols rather than having to calculate every single step. So that was my thinking on that, but I'm still working out where this will fit in and if it will fit in precisely. But Forth is definitely the best language of its kind. It's small and it's interactive and it's very flexible. You can get it to do a lot of different things. And you can easily implement it on hardware.
Okay, I have a question for Chuck Moore. I really wonder what your most used application does.
The application I use?
The application you mostly use.
It's a clock.
Ah.
I have a screen full of numbers. The date and time, the Julian day, moonrise, moonset, the number of days till things like daylight savings time. All of the time questions that I ask myself have got the answers. And it's a pretty display.
Yeah, that sounds nice. Thank you.
One thing I have done recently is a new character set. You may be aware that I've done many, many different character sets. This one is the prettiest and the simplest, and it has a unique property. Normally, what I have been doing would be I would generate a character as a raster library. I would have, 48 symbols representing the characters stored in RAM. It finally occurred to me that computers are much faster than they need to be. So instead of storing the characters, I store the code that generates the characters. And when I want to display one, I compute it. Computers are plenty fast to do that with no perceptible delay. And it saves memory. It adds flexibility. You can edit your characters on the fly. And you can invest a fair amount of work in calculating a character because it doesn't matter. So I've got pretty characters available on demand. I encourage people to design their own characters. It's fun, it's easy, and it gives you another customizable aspect of Forth.
Yeah, very, very nice. So there's something that is called display PostScript on Mac OS X, for example, or I don't know whether it's called like this. So this is something like display Forth. So a Forth program runs when you display text?
Yep.
Because it draws the characters?
Yep.
Yeah, great. I like that.
I'll show you the characters sometime when I can. They're very pretty in 4K. I can draw very large characters. They're all scalable and smooth curves.
Chuck, this is Don. You gave a talk, I think it was last Forth Day, where you were writing directly to the memory buffer. Is that what this system you're describing is? You're writing directly to the memory buffer?
Oh yes, you have to have that kind of speed. If you go through the Windows interface, it's much too slow.
Of course.
Hi, Chuck. This is Oscar Garcia. Hi, from the Interplanetary Networking Special Interest Group. I know you have been for many years interested in space and space exploration. Have you been working at some point about the delay tolerant networking and interfacing with Forth? what is called DTM.
I don't understand.
DTN is a protocol that using bundle protocol encapsulates TCP/IP or LTP, link glider transport protocol, to connect with the space. It's used in the International Space Station and also in Mars rovers. And I've been looking to different languages to interface with DTM. We are working with Binton Cerf in this project about interplanetary internet. And I would like to know if you have been interested at some point in this kind of communication.
I'm indeed interested, but I've done nothing in that direction. In fact, I haven't even been able to get onto the internet, or the tools that Windows provides are opaque to me. And I've just been forced to deal with things locally.
Thank you.
Hi, Chuck. My name is Bob Flanders. It's a pleasure to meet you, sir. Yeah, somebody just brought up the original listings.
It's me here, Bob. Nice to meet you. Nice to see you in the group.
Nice to meet you too, Peter. It's been a long time coming. There's kind of an interesting little story about what's on the screen. On 2011 or thereabouts, I got in touch with Chuck to ask if he had any old code for the IBM 1130, which was the first computer he wrote forth on, a fully working forth on, as I understand it. In fact, the name of forth would have been FOURTH had it not been for the 1130's limited file system, which only allows 5 characters. So it had to be named FORTH to be a file on the 1130, which is kind of fun and has led to the idea of it being something that we go forth. So anyway, in 2011, I sent a message to him asking if he had any old code for the 1130, and he said, yeah, I'll rummage around and he'll take a look and see what he has. And he found this, and he sent it to me, but I missed the message or something. Well, a few years later, I guess it was 2017 or so, Carl Claunch, who is a fellow IBM 1130 enthusiast, sent me a message that he had spoken with Chuck, and Chuck had said, I think I sent it to this guy Flanders, and but he'd since gotten rid of the papers. And so I rummaged around in my Gmail and I found it. And it turns out it's either a pre-version 1 or pretty close to version 1 copy of the code, and the basic kernel, the assemble level words, and then the additional words on top of it. And I had a tiny amount of contribution to helping Carl get it working on an IBM 1130 emulator. And Carl actually has a working IBM 1130, and he's gotten it working. There was one critical word that we probably would all be completely lost without, had it not had that wasn't there in this version, which was period. So you couldn't print out the top of the stack. I think that the top of the stack may have only been shown in the indicator on the 1130 for the accumulator. And it was a very interesting bit of work to put it together and get it running. There were some typos, or some, not typos, but some handwritten notes on the code, and there was some things that needed to be adjusted a little bit. Maybe also we made typos putting it in. And there's actually floating about out there a version 1/4 of the IBM 1130. The way I became interested in Forth personally was I was hired by MCI Telecommunications like 1986 or thereabouts. And I had no Forth experience, but a friend recommended me. And I came in and the guy said, well, listen, let's give you a try. First thing I want you to do is write a word that shows a timestamp. So I fumbled around and wrote a timestamp. Then the next thing he said is, I want you to implement drivers for a multi-port serial card. And I wrote that, and then he said, okay, you got the job. And I ended up working for 8 years using LMI Forth under some DOS extender to implement a system that ran on, at the end, I think it was nearly 1,000 what were called site controllers. And they were co-located at the various MCI facilities and talked to digital cross connects and extended subframe monitoring units. And it would send all the information back to a central computer, which would then use its interface with Forth to do things like, a customer call up, say, hey, I need a circuit from Washington, D.C. to Los Angeles, and they would go into the digital cross connects, hook up the T1, get it all running, and then go out and get it delivered to the customer at their endpoints to whatever provisions were necessary. And it was a very cool and interesting system. I haven't done much with Forth since, but I'm always looking backwards, like, oh, I want to do this. I want to work on, like, I'm writing 1130 emulator and things like that. So it's always of interest to me to do things with older code, not necessarily newer code. But I program in C# and do a lot of SQL stuff. I'm a radio IT guy kind of thing. So anyway, pleasure to meet you, sir. Thank you so much. Forth is brilliant. It was brilliant. It is brilliant. It shall continue to be brilliant. Take care.
Well, I can add a little bit to the 1130 story. It isn't as if I was sitting in an office working with the 1130. The 1130 was on the abandoned production floor of a textile mill. It was a huge room, about 200 feet long and 100 feet wide. And the exact center of it was this 1130, which had been delivered by IBM. And nobody knew what to do with it, except me. And so that was the environment in which Forth was invented. It was challenging in many ways.
Yeah. It was the 1130. If there hadn't been 1130 in my high school, this was about 1972 when I started using one. And at that time, I had no understanding of what I was doing. If it hadn't been for the 1130, I probably would never have gotten into computing. But that started my career. And,
First mini computer.
Yeah, yeah. Well, I call it my first personal computer.
Hi, Chuck.
Hey.
We've met a couple of times, and many of us here will remember the August 1980 edition of Byte, where you introduced the language to a much wider audience. But that was the time that you felt that the software had been done, and you are now looking towards the hardware. Could you tell us a bit about how you made that transition from software to hardware, and you moved towards the Novix period of Forth history?
yes, I did feel the software had been perfected in the context of fourth. What I was doing at the time was putting forth on many different computers and interfacing it with many different devices. And this, of course, is very easy to do. That's why fourth exists. But the interfacing with many different devices got very frustrating because these devices were badly designed. The interface I had to go through was bizarre, baroque. And I got kind of tired of doing that. And I said, well, I could design a better interface. I could design a better computer. Now, people didn't do that at the time. This was the business of someone else. So it took really a leap of faith to abandon software for hardware. And I actually didn't, because I had to develop the software to design the hardware. But thereafter, my software efforts went in the hardware direction, in simulators and layout tools. And it was very rewarding. My hardware worked. And it worked much better than anyone expected or even would admit. And I'm still doing that in the sense of the green arrays multiprocessor chips. They are incredibly simple, incredibly effective, and totally unpopular. So fourth hardware is just as unacceptable as fourth software.
Yep, and that's absolutely fine. Some people like fourth, like everybody here, I would imagine. Other people don't understand. Hi, it's Howard Oakford here. We've met a couple of times too. I'd just like to say thank you. You've made my career in programming much more fun than it would ever have been otherwise.
May 1,000 flowers bloom.
Thank you.
G'day, Chuck. I met you once back in '88, back in the we had an Australian symposium here, and and I've been using fourth since the early '80s. You know, I started a big project with that, and I've been using it ever since. And yes, you know, a lot of people won't admit that it works so well. You know, that's true with the hardware and software, and it also makes the hardware a lot simpler. We don't have to use any complicated hardware. And you know, like that was my original fourth board I did up, you know, with the Rockwell chips, etc. And then, you know, I got that down into a module, you know, a little credit card size module. But this is mid '80s, and that was okay for the mid '80s. And now I use the P2 multi-core processor with 64 smart pins, etc. And so I do a lot of embedded control. But this is a question I really wanted to ask you. You just mentioned the green arrays. It's got all these processors on there. I've got the parallax propeller processor. We've got 8 cogs, well, 8 cores. It has hub RAM, so it shares everything, and every one of those cores can access all the I/O equally. But when I look at the green arrays, I can't figure out how I can use it. You're saying it's an effective processor. What has it proved to be effective in, you know, really? How could I use it for general embedded control and smart stuff?
That's a good question. It has 144 computers. They aren't exactly cores, they're independent computers. They communicate with one another. And the ones around the edge communicate with pins. So if you want to control a pin, you have to use the computer which is attached to it. And that computer pretty much can't do anything except run that pin and communicate with its neighbors. So you end up building a little network of computers, not 144, but maybe half a dozen, that all cooperate and communicate in running the protocol on that pin. It's a fun thing to do. It's totally different than any other computer where you would just run a serial processor. Your whole attention is in coordinating the efforts of as many independent computers as you want. Now, I don't think I've done an application with more than about a few dozen computers.
So Chuck, so in talking about applications, what if you had to showcase an application, say, look, look how well it does this, and I'm bearing in mind too that from what you said already, there's a bit of work setting it all up for those cores to communicate with one another, or those little CPUs to communicate with one another. I'm familiar with the whole architecture, but what would you say? Which you could hold up an application and say, man, this does it so well.
Well, one obvious application is run forth. You can use some of the computers to drive a display. You can use some of the computers to read a keyboard, and you can put them together to run forth. I haven't done that. I never got around to doing that, although I got close. Each computer has 64 words of RAM. And one of the computers interfaces with a flash memory. So there's infinite amounts of data available. Another set of 3 computers can communicate with DRAM. So what you want to do is set up a system whereby you read code from flash, you store it in DRAM, and you read it back from DRAM and do whatever you want to do.
Yeah. So I'm wondering why you haven't done a PC with it yet. Come on, you can do it. But the thing is, okay, so I use chips, so that one's got 512K of RAM, and plus all the 4K RAM on each CPU, etc. And so it's really easy to make it work. And I talk to an IO, and I can even instruct the IO to do something by itself. It's a smart IO; it has everything built into it. I keep racking my brains looking at the green arrays, and I can't think, even if I could get it to do something, boy, it'll be a lot of work. It'll be fun, but it'll be a lot of work to do it. And you mentioned memory in displays, for instance. Well, there are a lot of more effective ways of doing displays, but I can do a VGA or even a HD display from the RAM on this one. But I have to bolt on all that RAM onto the green arrays. I'd really love to see a green arrays one that had less CPUs, had a bit more memory on each one, and more access to the IO. And it was like, that would be really great. 64 CPUs, forget about 144. Give me 64, and as you said, you don't need to use many.
We'd love to do that. We've had plans for doing that, but we've never been able to make such a chip.
Right.
We'd have to integrate someone else's memory onto our chip, and that isn't easy to do.
Yeah, well, I appreciate. I just wanted to ask you that question because it's like, it's the one thing that bugs me. It's like these Forth chips, going right from the early days, Novix and all that, and they're all really great. And then I've got Mach 21s, I've got the Shaboms and everything like that, but I can't figure out how to use the green arrays. So I'd really love to see some application, or even forget about application notes, but just a showcase, something that showcased that particular chip, how it was used really well.
Well, the biggest advantage of the 144 is it doesn't use any energy. So it's
Somebody have to put a lot of energy in to make it work, though. That's the trouble.
Yeah.
Yeah. Well, thanks, Chuck. Yeah, no, appreciate it all very much. All your work. You know, when we love Forth. The other question, I just wanted to ask you, nothing to do with technical things, but you know, we often talk about how is it that we can really promote Forth? You know, it's just that mindset. You know, you've had way more experience with encountering the opposition and with people accepting Forth. And it's like, well, I had Forth built into the chip and silicon on this particular P2 chip, and that was a hard task to get that done at the time. But Forth is a dirty word, you know. People just don't like, companies don't like mentioning it. It's just like, do you see anything that would help break down that barrier?
A killer app. We've been looking for a killer app for 50 years and haven't found one.
No, well, apps are PCs. You know, I think most of the Forth use, you know, I've always used Forth on micros embedded, and so they're built into airports and roadways and all kinds of vending machines, anything, you know, and so they're all out there. People just don't see it, but it keeps going 24/7. And it's also my prototype, the language that I use. You want a prototype? This, you know, people are used to using breadboards. Or Forth, you can move stuff around like that. You can fritz all you like with Forth, and it's very quick. So, you know, I have a project now where they are saying, hey, you know, do it with Arduino, you know, C and everything else like this. And I'm thinking they can ask me, but I'm still doing it my way because, you know, I can get it done. But yeah, but it's just that opposition to it. And I don't know if there's anything, we often talk about it on our group on Forth 2020, how we can get young people interested. It's not going to be a killer app. I think it's going to be the easy use, how they're using it, makers, how to makers use Forth, you know, can use Forth easily. Straight away, they say RPN.
I have a question for Chuck. Chuck, was the Sun Force in BIOS or open Force, how was the name? Open OS?
Open Boot.
Open Boot.
Open Boot from Sun Solaris.
Yes, exactly. Open Boot. Was this not the fourth killer app? Because this was installed in so many computers and also on the one laptop per child. I know this was a really big installation of Force.
Yes, that's true, but BIOS is such a obscure application that it didn't attract any attention. It was a technical triumph.
The attention that Open Boot attracted was attempts to replace it with conventional software. That didn't work. Forth didn't work because there was not an industry behind it.
That's always been a problem. We lack large-scale support.
Yeah, Intel came along and killed open firmware, not open boot, open firmware. And yeah, Intel was responsible for UEFI, and that killed open firmware.
But Forth really doesn't need corporate support to prosper. It's an individual thing rather than a collective.
As you did check with your Green Array's talk on, you did a discussion of that video, how you got the 144 chipset to drive the video. I was very impressed that you don't have generic video hardware driving the video in your demonstration. You had the Green Array's chips, each programming the timing, and that was significant of how you got the Green Array's chip to do video that wouldn't be normally required just to produce an output for people to see. In applications which don't really need consoles, if you're manipulating data, you work the data and you produce the storage of the output for later display for people to see. And so the video display was just a really fantastic ability that the chip array could actually program, and the speed. I think was absolutely significant was the power savings that your chipset did that nobody else could do.
And it was a lot of fun to program that VGA. And it wasn't easy. Timing was a big problem.
Yes.
And it was just fun.
I would say so too. It's quite unique that you've got this hardware and you're interfacing the Green Arrays into that hardware. So there's another incredible example of what the Green Arrays chipset can do.
It can bit bang anything.
Yes.
It's got the speed, and this is with an obsolete geometry, 180 nanometers. This is abandoned.
Yes.
And yet we're competitive with the 10 nanometer geometries.
You could equate the Green Arrays chipset to be a RISC processor, where everybody's going to sys type processors with multi instructions. What you can do on a RISC processor like the Green Arrays, it's so much quicker. It may need a little bit of effort to do the stuff that needs to be done, but clearly the number of instructions to do the work supersedes the performance that any of the standard processors can work with. And at the cost of power, which was so much cheaper on the Green.
I've got to jump in here a little bit about programming these machines, Chuck's machines. I was one of the first Novix programmers and one of the early Green Arrays series of processors. Jeff Fox and I, at the beginning, were doing our darndest to pack as much code as we could into those 64 words of RAM. Over years now, we found that the smaller amount of code, the smallest amount that you can put into a node, lets them use the least power, because each node is cooperating, sending messages between them. And when it isn't running, it's only got leakage power going. So look at, for the earlier speaker about getting into Green Arrays programming mind mode, look at the examples that are on the Green Arrays website. You'll get a lot of that. One of the things that I did sort of as a skunkworks program with a good friend of mine, Bill Minch, who was also an early programmer for the, I think it was the 24 processor chip, was to implement a virtual machine to execute eForth. And we put Bill was the originator of eForth, and Ting has taken off with it in assembly language. We did it all in high level. And we built a virtual machine using, I think it was 3 or 4 of the nodes to execute eForth opcodes, 8-bit opcodes directly. And that has facilitated, actually, it's been moved, and Greg Bailey's version of Polyforth, Forthinx code, is now running virtually on the Novik, on the Green Arrays chip. And all of the development that's happening currently is being done in standard Forth. You do not need to know the details, just like every other processor. So take a look at those application write-ups on the Green Arrays website.
For example, if I may, 10 words of code forms an Ethernet Manchester decoder and receiver, converting the wiggly signals on the twisted pairs into bits going to the next node.
Wow.
You know, I listened to all this and I think, wow, this is the stuff you guys are doing are incredible in little chunks, right? And then there's a question of how could something like Forth be taken? How do we take Forth to the next level? How do we take it to, you know, push it into the future? I'll tell you something, you know, I watched this one guy on YouTube, his name's Jeff Geerling, and he's trying to deal with taking a video card and getting it to run in a PCIe single lane on some of the new Raspberry Pi compute boards. If you could do something like build a Forth-driven video card with an open interface that could be, you know, could be added to the drivers and such could be added to, that would have some kind of a standard interface that's like, you know, will work with OpenGL, or I don't know what the current, the modern, the current video standards are. If you could build something like that, that would then sit in like a PCIe one lane PCIe slot, you sell 1 billion of those, because there'd be people, they're going to, the CM4, the Raspberry Pi CM4 things are becoming incredibly popular to build small, like, you know, systems with a bunch of slots in them and stuff like this for multiple CPUs, and then having a you know, a PCIe card or something like that sitting in there to show, have a video. It seems
Chuck
like
is
that would
busy
be a
building.
project.
Bob, thank you. Chuck is busy building a thing called HD Forth from his last discussion, and that seems so significant what he's working with on an HDMI interface. It'd be interesting to see further development that he's working on his HD Forth.
The HD Forth has evolved into what I call UHD Forth.
Even better.
For the 4K display.
Wow.
It's running on a PC, x86. Its unique characteristic is that a lot of the code is in assembler. Well, is in machine language. And there's no assembler. There are hex opcodes for the x86 instructions. Now, I had to memorize those opcodes. But it was as easy to memorize the opcodes as it was to memorize the assembler code. And it gives you beautiful versatility and efficiency. completely unportable. But that's what I use. I call it color forth, but that's the versions I'm using now. And it is the nicest fourth I've ever had because it gives me the closest interface with the hardware. On the other hand, in the old days, when you wanted to interface to a chip or a board, that chip or board was documented. And you could merely download the spec sheet and work with it. Nowadays, there's no documentation. The best I have found is in Windows, but Windows is incredibly complex, incredibly obscure, badly designed, almost impossible to work with. And I work with it when I must, but it has turned me off trying to interface with the larger world. As I said before, I've never been able to figure out how to get on the internet. The world has changed, and I'm afraid it's changed in such a way as to disadvantage us, the, well, call us hackers. You're supposed to sign on to the corporate vision of computers. And if you don't or can't do that, you're being left behind. Perhaps some of you know Werner Vinge's science fiction novels. He has one called Fire in the Sky, something like that, in which the problem of buggy, enormous software was mentioned. The spaceships of that era were programmed in some obscure language that nobody could really master. And it was determined that you should rewrite the software so that it was simple, clean, bug-free, and entire planets attempted to do so. They could not reproduce all of the obscure bugs in the existing software, so it was not useful on existing spaceships. And the whole project led to enormous costs, effort, and failure. That would equate in today's view with trying to reprogram Windows, say, or Linux in forth. It probably can't be done. It certainly is not sound like much fun because you have to reproduce the bugs.
Who wants to reduce bugs? You want to get the bugs out.
For instance, what you really need is just an IP stack, an Ethernet or Wi-Fi interface. And once you have those, you're pretty much good to go.
Sorry?
The hard part is the Wi-Fi interface due to proprietary firmware, though.
Yes, exactly. That's why I went to the 144. Rather than try to interface with the existing world, I wanted to try something different, something standalone. Now, the 144 could drive a GPU. I don't know how to do that. I don't even know how to find out how to do that, if it could be done. I mean, if it can be done, of course, but whether you can figure out how is a completely different question. And I've given up on that.
Chuck, here's a challenge. if you were to develop the 144 to do Bitcoining, everybody will stop using the GPU processors, and the sales of the 144 would go through the roof. And you'd be making money over money, because the people out there wouldn't realize just how fast the 144s could process the hash tables.
Quite right. But among other things, it takes money to develop such
Right.
an ambitious application. And we don't have any money.
Oh, right. Okay.
I have an open question for you, Chuck, if I may. First of all, let me say that I feel very honored to speak to you today. I mean, Forth for me was a fantastic concept since the 80s when I was a student. So definitely it's a wonderful experience to speak to you. Now for the question, it's related to IoT. Since Forth is by design very efficient in terms of power consumption, in terms of processing efficiency, I'm surprised that Forth is not more commonly used for all developments based on IoTs, where of course energy consumption and responsiveness and real-time aspects are absolutely critical. What do you think about this?
I think that's an absolutely wonderful application area. And Green Arrays is projects which are trying to address that. The fact that we use very little energy is a no-brainer. But we haven't found the killer app.
If you will, next week I have to go and explain to a professor at University of Wyoming why the fact that we don't run standard high-level languages in a pair of streaming glasses is not a killer of our technology. The point is, the reason why people don't use our chips is that we don't have these giant, fat libraries of crappy code which they can glue together, which is all they know how to do. They don't know how to write code. They don't know how to program. End of story.
No, that's a fair statement, Greg. And I personally developed some robots. And I mean, having to use the ROS, the robotic operating system, with I mean, huge overhead code for me is a waste. I mean, I would much prefer and think that would be much, worthwhile to use Forth for programming robots, at least all the layer that relates to the control of the actuators. So
the thing with all those libraries is that you end up getting dependencies upon dependencies upon dependencies. And while programmers like gluing together their libraries, in the end, it ends up biting you because they take so much more space. You have reliability problems that if anything in the whole chain of libraries breaks down, your code breaks, but because it's not in your code, you don't have any control over it. You have to just either beg the original developer to fix it, or you have to fork their code and fix it. But then if it's in code that other people are using themselves, it involves all kinds of dependency problems and all that. And in the end, all these libraries and conventional code become a liability, not an asset.
I'd like to comment. The killer app is embedded AI and robotics. That's the killer app.
I agree that embedded is the key area for Forth today. That it is the area in which Forth has a true advantage, because the only things we see competing at all with Forth are the likes of MicroPython, but those of GC, which kills real-time performance and which is big and bloated by embedded standards.
Don, would would you see something like a crypto mining fourth? Could you use Green Sky to do crypto mining? Could you use, maybe perhaps several Green Sky chips to put together something that would be capable of crypto mining without using a hydroelectric dam's worth of power in order to make a Bitcoin? Just a question put out there. I don't know.
So this is actually a space that I'm in. So I think if you for mining, you need to have some high computational fabrics, but you could use something like a Greenaway to glue those together, kind of what Chuck is alluding to, doing a GPU. I think, but that gets actually into a bigger issue. I think you could you could make an argument that the history of computing has been a dichotomy between two views of computing by two different Charles Moores. You got the Intel Charles Moore going vertical, right, with Moore's law, and we're packing more transistors per square inch in there, and it requires more power. But it allows us, so you're building on this vertical space. It allows us to think about single sequential computations, which is a lot easier for our human brains to think about. So there's easier to code for, and and just because of the nature of technology, we've been able to scale up and scale up and scale up. And now we can't do that anymore, right? We're seeing that we have to go horizontal. We're getting more cores and all that. Well, okay, the Chuck Moore model is eliminating complexity and doing lots of little small things that are going to be emergent behavior. Well, guess what? So you mentioned Bitcoin. Bitcoin is the first decentralized computing platform that's truly, ground up decentralized. Crypto ledger type applications, everything being fully decentralized, requires everything to be really super simple, completely decentralized emergent behavior. And you can't have all this complexity sitting on top of it, because it becomes impossible to reason about your software. So instead of talking about looking for a killer app, I think of an app. It's really an argument between platforms and protocols, right? So something like Facebook is a platform, but a protocol would be a way for lots of small things to communicate in some manner, and each part of it would have fewer resources at each node, but then as they cooperate together, they would have emergent behavior. I think if you see FPGAs are sort of making the line between hardware and software get gray, and you'll see a lot of, and on the FPGAs you see a lot of them now have GPU type features in there, and then the FPGA is sort of the glue between it. So super specialized large hardware is going to be less and less reasonable. I think we're going to have more specialized hardware that can reconfigure its fabric based off what the application needs are at that time, and so you can do really, really efficient stuff. If you consider that any good fourth application is really a domain-specific language to describe your app, and then you write your app on top of that, that is the type of computational model that's going to be necessary. Because the real world, the vertical world is sort of a lambda calculus. Everything is a single thread of execution. Step by step is how things go. But the real world has unbounded non-determinism, and that can't work with the lambda calculus model. That can't work with the vertical model. That has to work with a lot of different independent computers talking to each other, and the emergent behavior that comes from them. So you can, an individual can think about a single compute at a time. Probably the closest thing that I've seen that I could say is a successful demonstration of this sort of model is Erlang in the telephony world, because they have an actor model of a lot of small independent nodes or processes, which are independent computers. They talk to each other through message queues. And you just the GA144 is just that model gone down to the hardware level. It's just everything is a generalized computer on the GA144. If there were some GPU fabrics or some other specialized stuff, then you could do anything that is being done in the blockchain or the crypto ledger world. That would be the kind of model that you do that on. By the way, the virtual machine that Bitcoin runs on, Ethereum runs on, all that kind of stuff, they're small stack machines. Their low level code is very, very Forth-like. And so this is a space that I'm working on. And I think it means now that the direction forward is the new Chuck Moore model. We have to go horizontal. We have to start adopting that. We have to start thinking and reasoning about things that are working in parallel rather than vertically. So that's what gives me hope for a resurgence of Forth, because it's actually Forth all the way down to the bottom now, and people are not realizing it. They're using languages that have a huge impedance mismatch to talk to these platforms, because the compilers have to convert between it. A Forth-like language has a much better match to what's the underlying hardware, the hardware being the virtual machines that all this stuff is being built on. So that's my hope for Forth. That's the killer app. It's really killer protocols. It's not apps. It's not platforms. It's protocols.
Very cool. Thank you. That was cool.
Wouldn't you actually want something like using ASICs for doing your crypto work, and then using something like, for instance, if we're talking about green arrays, something like that to glue together the ASICs to implement doing your Bitcoin mining?
Precisely. That's you need this kind of stuff to glue all this specialized hardware together, and you need a programming language that lets you reason about things in that way instead of just being sequential computation all the way down.
I agree with you on
Chuck.
2 points, Ben.
Oh, you're right.
One of them is that our hardware is absolutely unsuitable for doing SHA-256s forever, all the time, 100% duty cycle. And that is the nature of the problem of mining. The problem of mining is 100% duty cycle, flat ass busy, doing algorithms you cannot, by definition, simplify. And that's how we've always worked our magic. Okay, Chuck's returning to first principles and redefining the problem does not work when the problem is a crypto algorithm. If you change anything in it, will not work any longer. And if in fact there is a way to simplify it, that is a weakness in the crypto algorithm, needs to be fixed, and would probably doom that algorithm forever. On the other hand, EOS, okay, for its smart contracts, has a stack machine, which they're programming in some stupid language that doesn't admit a stack exists. And that's the most asinine thing you can imagine. I sent them a proposal, they ignored it. Ha, 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 too bad.
Well, I'm working specifically in that area. I'm building a Forth-like language called Actor Forth that uses an actor computation model. The other thing about it is it's to allow it to be able to scale up. And when I mean scale in terms of number of programmers who can look at the application at the same time. It's built on top of a dependent type system. So that's one aspect that's very different. But I think that's what's necessary for a crypto ledger application to have some sort of safety into it.
So it's basically like marrying Forth with Agda or Cock.
Those kind of thoughts, yes.
Excuse me, this is Christian Hintz. I'd like to say a word.
Go ahead.
I listened to all this conversation, and I realized that most of you, see, I'm a beginner, and I'm not at the same level technically, even though I'm an electronic technician, but I realize that most of you are free minds that decided to create outside of the box, just like Charles. And I will, if Charles is still there, I'd like to thank him for giving us a model of a free mind that was willing to fight the conditioning of the box and provide true innovation. This is what I perceived in Fort when I first looked at it in 1980. I was 20 years old. I was a bit too old as a kid. Today, they start to explore at the age of 6 or 7 with Scratch. Well, I started with Fort. Fort was a language, very close to the human language. The first few lines that I read describing Fort use words like dictionary and words. This is what I used in school. I knew what it was. It was not computerized words coming out of university. This, Charles, thanks for creating a language that is close to humans. This is what I enjoyed in Fort in 1980, and this is what I still enjoy at 71. I think all humans enjoy things that are close to humans, but our society is providing us with a lot of technology that we lost contact with. We don't know what's behind that black box that we use every day. We have a cell phone in our hand, and people don't bother knowing what's inside that cell phone and what it takes to make it work. Our state of mind today, conditioned by the type of education we have, has made us users rather than creators. There is still a few people out there. Most of the people doing programming are creators. And thanks to all of you for doing this. And I just hope that we'll find a way, a channel somewhere in university to keep creativity alive in the high level education. Because right now we're conditioning people more than we're educating them to create, innovate, except for a few free minds that make it all the way to doctorate. So thanks everybody. Have a nice day.
Thank you.
Hello, everyone.
Yeah, so, yeah, sorry. Go ahead.
I'm
think
sorry.
Greg's got his hand up.
Yeah,
Greg.
I just wanted to share some of my own thoughts. You know, throughout my career, I really haven't had the opportunity to use Forth, although I've come close. I've used it mainly for my own projects, but I would have to say that it has influenced my work. The Forth philosophy, if you will, has influenced my view of things and software development in general. I mean, the concept of simplicity, of extensibility, being able to develop, solve a problem through a language-oriented approach, being able to refer to concepts in the domain crisply by name and so forth. And this was a concept that I also came across in the book, Structure and Interpretation of Computer Programs by Sussman and Abelson. It goes back to the mid-'80s, and there are some lectures. I highly recommend them. You can find them online that talk about language-oriented programming. They also talk about some mind-blowing concepts related to functional programming, but that's a whole nother story. But I wanted to say that more than anything else, Forth has driven me to try to think simply about a problem and to find simple solutions and to recognize that. And unfortunately, it's rare that I see code in the industry that matches that expectation, but I try to strive for it myself. And one thing I wonder, I work in the industrial automation field, and what I've been involved with for the past 30 years or so is we develop the software that our customers use to program our systems. We develop the editors for function block, ladder language, and all the other control languages that we support. And what I've noticed is we've gone through 3 generations of products. We're currently working on our next generation product. Our first generation probably took maybe a year or 2 to develop by about 20 people. Our second generation product was maybe 3 to 4 years of 50 people. We're currently working on an enterprise level project that involves hundreds of people, and it's looking like it's going to take a decade to develop. And what I wonder is, what is the future of software development? I mean, this seems like an exponential curve of complexity that we're moving towards. It doesn't seem sustainable to me, and I just wonder, is there going to be a reaction to this ever-growing complexity, and is there going to be a movement towards simplicity? And I'd be curious on people's thoughts on that.
Well, Forth is both provides power and simplicity in a combination that you rarely see anywhere else. That most other things that are either powerful or are either complex, and most other things that are simple, such as BASIC, for instance, in the traditional line numbered form that you saw in old Microsoft BASIC, lacks power. Forth is one of the few areas in which you have both simplicity and power, such that you can make a single person in the space of, let's say, a year or 2, can develop a full native Forth compiler combined with an RTOS all by themselves, and understanding the entire thing as a single individual. Whereas, tell me what other kind of, outside of Forth, what other kind of environments in which that's even really possible to develop something with that kind of power in that shorter period of time while being fully understandable by one person all by themselves, rather than having a team of people where each person understands part of it, but not the whole thing.
Agreed. Forth is an amplifier.
But I mean, we are facing a technical problem here, right? A technical problem that feeds into marketing, which feeds technical problems back in the community. So that's a self-supporting vicious circle. What we have is hardware manufacturers who have to stay in business.
I'm sorry to interrupt. Cornelius, can I ask you a favor? Can you turn off your video?
Shiny new devices.
Yes, your mic is quite
We, on the other
noisy,
hand, have
like
software
it's very choppy.
manufacturers, just such as Apple and Microsoft, and in the Android space, Google.
It's not working, Cornelius.
To keep attracting
can't hear you.
customers, keep clickety.
Yeah, we can't
It's
hear
this.
you, Cornelius. Sorry.
Is
I
this
can't understand
anyway?
anything.
If okay,
Yes.
let's
Yes,
try
it works now.
this.
Wait, it works now. Yes.
Let me kill one more. How now?
Perfect.
Yes.
Yep. Excellent. Cool. I need a new Chromebook. Anyway, the problem that we are facing is we have 2 industries that feed off each other to feed us stuff that we might not really need. The hardware industry needs to keep selling more and more nicer computers to all of us. So therefore, your old gear is going to be obsolete in maybe 2 years. The software industry does the same thing by requiring the hardware manufacturers to come up with new stuff, like think Microsoft Windows 10 will no longer run on certain old CPUs. You need newer gear. If you look at the productivity aspect of it, I dare, from my personal perspective, there is nothing in Windows and Office that would better my productivity with these two since Windows 2000 was around. Windows 2000 did everything it needed to, and Office 2000 did it too, and peace be. Yet we have more and more complicated stuff that gets more bloated on the software side, so it requires bigger hardware to use. And as long as folks stay hooked on that, there is no motivation for anybody on the commercial side to do anything different. Now, if you take a look at the maker community, if you take a look at all the projects in the maker community, Forth, inside and out, elsewhere as well, microcontrollers rule the roost. Raspberry Pis happily play the host or act as microcontrollers or play the host to some microcontrolled environment because, hey, you have a cheap microcontroller, why not go with an unencumbered cheap host, drive the thing? And that's quite frankly is the spot where Forth and other low-level stuff have their future. You will never ever you're not going to be able to penetrate the mass market because the juggernauts of heavy industry own that space inside and out. And as long as there's no pressure on consumers to maybe buy some decent gear, and decent is not what you see in a commercial, the market for Forth and similar environments is going to be an industry niche, specialized industry niche, not necessarily limited to AI, where specialized, fast, and furious solutions are required. I shall shut up now.
Good point. Thank you.
Can we get a few more questions for Chuck?
Hello, Chuck. Is my audio audible?
Yes, it is.
Yes.
Yes, fantastic. Hello, Chuck. I'm honored and very happy to be presenting to you and to the whole community. I mean, I'm so happy, and like I'm gonna share the screen on the other computer because like I've been trying to like share it, but it didn't work. But I think this works even better. So yeah, I mean, this is actually like a system that I've been working for like a year, and I think like in like 7 years in total. And I actually tried to understand for it, but it didn't actually make sense to me because like, I mean, it made sense in the sense that I understood that there was definitely something here that was incredibly interesting in terms of like capability, but the performance aspect of it, like I'm obsessed with performance and optimal like representations. So like that didn't make sense in the runtime, but I think in the low power sense, it made like, you know, in the low power designs, it makes a lot of sense, right? Like to have like a super simple core that is still flexible to execute like any kind of logic while like still like keeping like a small size. And the other side of the spectrum, I think like, you know, is the tooling, which I think hasn't been explored. And I think it's super interesting. So I'm like, so this is like, it's actually like an embedded editor. And I was super happy to hear that, like, so this is actually the font design that I teased earlier. Like, the language looks like, you know, from bottom left to top right to bottom right, etc. And that we use the A character, for example. And like this gets transformed into signed distance field lines, and that gets rendered with like warping with the screen, all inside this like custom color fort, but it's actually like prefix parsed, right? Like, so it's a custom character set, and like it's prefix parsed, but in the next version I'm going to explore like postfix parsed, which is like, but yeah, I mean it's I think what's super interesting about Fort is it's a meta language, like, and how have you explored Fort in like as a meta language? I don't have a question actually. I don't know, but like I think Fort as a meta language makes like a lot of sense. So I'm actually doing like a really bad demo, I guess, but I mean, yeah. So like this whole environment is written in a mixture of C, assembly, and this language itself, and like the point of programming is, I think, like, you know, that works anywhere in any scenario is to generate. Like, we're just generating code from. So Fort is like a programmable compiler, but we have to define the compilation logic to generate whatever we need, instead of thinking about like, oh, we have to actually, like, you know, use the hardware, like stack argument passing in the hardware. Like, I think that's actually, like, you know, very limiting in terms of like design space exploration. And I think, like, in the meta sense, like the hardware space is like, you know, it could be very interesting. Like, you know, we could have, I don't know. So it's just like, I'm just rounding, I guess. But, you know, it's
Yeah, can we get some questions for Chuck? That would be what I was actually.
yeah, I mean, the question is, what do you think
Well,
about
it was no
versus
question
like,
at all. I see there is no question.
Runtime Fort, I guess.
Yeah, I've got a question for Chuck, if I may.
Yeah, please go ahead, Ken.
It's a historical question, Chuck. When you made the transition from software to hardware in the very early 1980s, did you prototype any of the early Forth hardware using, I guess, TTL at that time? Before you moved to the gate array of the Novix, did you prototype any of that stuff? Thanks.
Yes, I did. I did build a prototype of a Forth computer in TTL or CMOS chips, which was sort of a proof of principle. But then I moved to simulating the gate array as a more helpful design tool in Forth. So the Forth hardware prototype wasn't really helpful, didn't go anywhere. It only helped to convince some other people to support the gate array.
Okay, thanks. That's quite fascinating. So I guess you were on the transition between building prototypes in hardware to simulating them. By 1981, 82, I guess we had 16-bit PCs and simulation became a reality. Yeah.
So I see Jared raised his hand.
Yeah, hello everybody.
No, now you're muted. Now you are muted. So We just had a couple of words and then your mic went off. No, 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 no.
No sound.
We can't hear you. It just broke. Yeah. Aha, now comes the mic.
No sound.
Can you hear me?
Yeah, yeah,
Yes.
yeah.
Sounds good.
No, 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 no,
No,
not
it went
now,
away.
not now. Not now. That's strange. It was just, again, just a word. Then it
Maybe
faded
if you
away.
log off and log back in of the Zoom, like drop, if you're having
Mhm.
problems with the audio, sometimes that fixes it.
Yeah.
You may
Oh,
get
yeah.
a message
We're not written in
to
fourth.
reinstall
Yeah.
the Zoom software like it happened to me.
Reinstall Windows. Yeah, whatever.
You won't have to do
Join
that. Just
Windows.
drop out. Just drop out
I
and
want to
come back in.
I put on the chat something that Chuck will love to see.
Mm-hmm.
I will put this on the chat. Probably you have seen, some of you, I started watching yesterday on Netflix, the $1 billion code battle of over Google Earth and a German company called TerraVision. It's absolute amazing, a fantastic film. And this has to do with this killer app we were speaking before. This is very interesting to watch.
Thank you.
Mm-hmm.
Okay. I've got a question for Chuck. Yeah, I'm just curious about the changes in Forth from the sort of the classic Forth from the early 80s through to color Forth, and some of your observations and reasons for the kinds of design, the way Forth has gone from the classic Forth to the Forth you're using now. What was some of the reasons that drove some of those design decisions in the more recent versions that you're using now?
Wow. Forth was originally an interpreter. And I had to learn how to make it into a compiler. And that was largely a question of confidence. The model I used was a Belgol, developed at Stanford. And I was a graduate student at Stanford. And there's this team of half a dozen people who wrote a Belgol compiler. And I said, well, if they can do it, I can do it. And so I wrote a standalone Forth. That was the first one. The criteria was to make it simple because I couldn't do anything complicated. And I think all of my later developments of Forth implementations were to try to make it simpler. Originally, Forth had a threaded dictionary, and that hung on for a long time, perhaps until UHD Forth. Now I don't have a threaded dictionary. I have dictionary broken into pieces. Each piece, there's each array. One array contains the words, another array contains the parameters, another array contains the code address. This lets me search the name array with this hardware instruction. But really nothing has changed. I'm amazed that the original concept structure of Forth with its dictionary and stack has remained for 50 years without significant alteration. At the moment, I don't know how to make it any simpler. And of course, the hardware has changed. It was originally memory constrained, and now it's not. If you have infinite amounts of memory, Forth doesn't know how to use infinite amounts of memory. It's just not necessary. So I don't know where to go from here.
I have a question, Chuck, which is not about technology only. I mean, and as Christian said, I mean, you are a free mind, right? What is the topic? I mean, considering the news, considering the way the world is going at the moment, what is the topic that makes you passionate about at the moment? Could be Forth, could be AI, or could be something not about technology.
AI goes back to my early days at the, what they call them? The early neural nets. I'm of two minds. You can see this played out in the full self-driving cars. Do you use artificial intelligence or do you use pre-programmed decision making? I'm a pre-programmed decision maker, so that's the way I do things. If AI becomes magic, as it has in the case of Go and chess, I'll be disturbed because we can't understand how it does it. If we get AI in the form of a mobile robot or a mainframe in the cloud that we don't know how it works, I don't know that we've accomplished anything. If you've got the oracles of ancient Greece who can answer your questions, how is that different if an AI is answering your questions? But I don't know what side to come down on. I think I will stick with my deterministic clock and perhaps try to get precision time protocol implemented or something like that.
Yeah.
Chuck, this is Don. You know, we're working on this FPGA based Forth. And I'm very curious about your comments on the dictionary because we haven't implemented the outer interpreter in the dictionary quite yet, you know, the compiler part. You said that you have three arrays. You have the CFAs, you have the strings, the word strings, the name of the words, and then you have the data. What's the data? Because the data is usually on the stack, right? So
in the case of a constant, it would be the value of the constant.
Oh, okay. So that's, yeah, it's a constant array.
Well, it's an array of, you can put anything in it you want. The address of a variable, the value of a constant. I think those are the only two I actually use. But you have to have a data field. And in the case of a code reference, the data field merely indicates that it is a code reference. But this has led to the most efficient implementation of all of these things that I've ever had.
I have a second question. You know, I'm in the space business now. I'm working on space robotics. Yep. Forth has a very rich history in space. Your RTX especially. I know that talking with Dr. Ting in 2010, the Goddard Space Laboratory had him do some work implementing Forth for one of their missions. Can you talk a little bit about the history of Forth in space?
I programmed a reconnaissance satellite once. But I had very little to do with it because the NC 4000 was the prototype of the RTX. And yet I had no contact with it at all. Nobody ever asked me a question. Nobody ever paid me money to do anything. So that whole space application went on without my participation.
So most of the space stuff was done by Fourth Inc. and Elizabeth Rather's people. Well, they were kind of the central focus.
John Hayes and Hopkins University, for
Yeah,
example.
Johns Hopkins University crew.
Well,
They were good people. They, what was his name? Proved that Forth was a provable language, which was an issue at the time. You could prove it was correct. Although I don't know why that is interesting, because it's pretty obvious it's correct.
Well, what's very interesting right now that I found being in the space business is FPGAs are naturally radiation immune. So they're very much favored in space because the geometry is much larger than the modern microprocessors, right? So a radiation hit is not going to impact an FPGA. And I think this is a huge opportunity for Forth. If you can imagine 100 robots working out in Pluto, assembling something, and you have this low-speed data link, and you're going to send a C binary blob up there every time you want to change code. You know, Forth is interactive. You just make your core words deferred words, and you update as necessary using text. I think it's.
But the same thing applies to the over-the-air updates that Tesla uses. I don't know how they do it, but I doubt they use a Forth model.
Okay, we have a queue of people that raise their hands to ask questions. So Dimitri is next, as far as I know.
Yeah, I put my hand up after Don. My question for Chuck is, okay, I've got a few, a finite list. What would you say are the most important things about Forth that someone learning the language needs to know? I'm interested in those who are learning it today. I myself am quite young. I've learned Forth in the past couple of years. So I was wondering what are your thoughts on this?
The first thing you have to learn is how to handle the stack. Conventional programmers don't think in stack terms. And there is a transition that takes, maybe a couple of years before you really know what to put on the stack and what not to put on the stack, and how to keep the stack clean. The processor used in green arrays chips has a circular stack. So you can put things on it, leave it there, and it will be forgotten in an optimal way. You don't ever have to keep the stack clean. And that's what I do in UHD Forth also. I have a circular stack. It's a little more expensive, but it's a lot easier. Beyond that, you've got to learn to factor. Take a problem, break it into pieces, give names to each line of code so that you can combine them into a higher level structure. That's not unique to Forth. That's a term, that's a kind of good programmer practice that no one uses. C has made it conventional to use very large subroutines with lots of parameters. And fourth has very small subroutines with almost no parameters. You have to make that mental transition.
How many things do you recommend leaving on the stack at a time? Like how many things in the stack should a word consume? Is there any rough guide on that?
One or two.
One or two, yeah.
The GA144 has 8 deep stacks. It does it, or 16 deep stacks. Whatever, but my UHD4 has 8 deep stacks. That's all you need.
Yeah, I think on the FPGA processor I'm working on with Don, yeah, we've implemented circular stacks, and I think it's 32 at the moment, but I thought 16 might be a reasonable depth for fourth programming. So that's reassuring to know. Since others have their hand up, I'll ask my next question, which is, what was it like working with fourth compared to Fortran or Algol? What was it about Fortran or Algol that made you think, I need to develop the language fourth?
Interactivity. As others have said, in Fortran, you have to recompile the entire application. Now, I worked in Fortran. In fact, an early version of Forth was coded in Fortran. And it was a pain to have to recompile the whole thing. It took half an hour maybe. And I wanted something that was easier to patch. Now, there are 2 flavors of Forth that I've seen. One is where you have a large body, a large dictionary with many things in it and different vocabularies. The other is which you don't know vocabularies and you recompile apps on top of each other. That's the way my UHD Forth works. One of the most common apps I use is the editor. It overlays whatever other app might be active because clearly it isn't interesting any longer. And it compiles a new version of a block. And then I can recompile the app, recompile that block to make the new app. So my compile times are 0, my edit times are trivial, and the application is tiny. So I have a lot of tiny apps instead of one huge one.
Wow, so that really is fascinating. And I've tried out using blocks. I think it's implemented in the ESP32 Forth, and I found it very, very handy. My final question, which follows on from the previous one, is: do you think that Forth still has these advantages that you mentioned? Do you think it still has these advantages over languages today like C and Java and Python?
Absolutely. I haven't seen any progress in the conventional language world since Fortran. All these languages are in fixed notation. They are not interactive. They are huge. If nothing has changed in the last 50 years.
What would you say is wrong with infix notation?
It's a perversion of notation and concept and implementation. In high school, people are taught infix notation as algebra. And it is a pain because it is unnatural. The HP calculators are much more efficient that in keystrokes than an infix calculator. It's just a path that society has taken that I think is suboptimal.
Yeah, I would agree with you. And that concludes my questions, by the way. Yeah, I would agree, because I had a bug recently at work, which was caused by an infix operator that I got the precedence for it wrong. And so it was evaluating it completely incorrectly. And I was thinking, if I was using Forth, this would not happen. And it's amazing how often people run into these things. You see problems on Facebook sometimes where someone says, solve this maths equation. And it's because it's confusing. These rules are confusing. They're good for mathematics, but they're not actually as intuitive as people think they are. They're only intuitive because we're taught them. But yeah, that's it from me. Thank you for answering my questions, Chuck, and I will continue learning.
Sure.
Yeah. Yeah, thanks. So next with the raised hand is James Norris. Please go ahead. We can't hear you, James.
There we go. Can you hear me?
Yep, now.
I was wondering about the x86 hand coding that you're doing. Would you consider using assembler, or why don't you do it?
Assembler is just another layer of software that gets in your way. What I have is the hex opcodes with subscripts. In other words, I will put a number on the stack, and the subscript indicates how many bytes that will take in the object code. And stringing these numbers together gives you a program. Now, this is totally inappropriate for large programs. This is insane. But for a one-line Forth definition, it's trivial.
Would you be interested? I wrote a Forth-based x86 assembler if you ever want to do anything bigger. And my second question is, what about using Forth as a, like right now they're coming out with Rust trying to do this. They figured out that a lot of programming languages have problems, like C++ has memory management problems and things like that. And it causes all these expensive bugs for like Microsoft and stuff. And they spend millions of dollars trying to fix bugs in their operating system caused by the programming language. And so now they're trying to come up with Rust as a magic solution. What about Forth? You could take Forth that's really simple. You could put in all that error checking that doesn't have. What do you think about that?
Yes, you certainly could. Forth doesn't have to be a standalone language. It can be a module in an operating system. It just doesn't seem to strike people's fancy.
That was all my questions.
Okay, thank you. So Gerald's next try.
Okay, next try. Can you hear me now?
Yeah, wonderful.
Oh, very sorry about the blur before. So Chuck, I wanted to ask, just because you also mentioned before that not a lot has changed in Forth regarding to the basic structure of having a directory and having a stack. But I actually recall having a discussion with you where you mentioned investigating multiple stacks and using locals even. Did you do any further research, or is this just been a short excursion for you?
No, that didn't lead anywhere useful. What I have done in UHD Forth, I've taken advantage of all the registers that the x86 has. And you could almost say that you could make a Forth register-based instead of stack-based. And I explored that a bit and abandoned it.
And why?
The stack is absolutely essential. You might not use it all the time. You might take advantage of the registers, but if you don't have a stack on which you can pass parameters, you're crippled.
And why did you give up on having even more stacks?
I don't use floating point arithmetic, so there's no reason to have a floating point stack. And I have never found a use for any other kind of stack.
Okay, thank you.
Right, thanks. So our next question comes from Greg.
Yeah, hello. Hello, Chuck. It's a pleasure to meet you. Actually, I was curious about something that was said earlier. You mentioned as a general rule, just limit the number of things on the stack to maybe just 2. And so just as a possible example, if I were to develop a word that is to draw a rectangle, and it takes 2 points, top left, bottom right, let's say, as parameters, that would be 4 arguments on the stack. So I might think, well, maybe I should start thinking about structures. So maybe I'll create a structure that's a point object. And so I could put 2 points on the stack, and that's only a couple of things placed on the stack, but now I have a structure. That structure would be, I think in fourth would be typically global, which some people might look askance at and say it's a global variable. I could also think of it in terms of, well, maybe I could create an object called a rectangle, and the rectangle might have methods to set its points and to display itself, or whatever I decide makes sense. And that, I think, fits well with the noun-verb structure that fourth, I think, encourages, object, action type of thing, machine on, machine off sort of thing. Just curious as to what your thoughts, would be on how you might structure, and your thoughts, a problem like that, and what are your thoughts on structures and objects and that level of abstraction, in addition to just the basics of what fourth gives you.
That's one way of doing things. What I do is I have a word at that sets the cursor, takes 2 parameters, and specifies the location on the screen. And then I have another word called rectangle that has the dimensions of the rectangle that I'm going to draw at the cursor. So I've broken it into 2 pieces instead of having one large piece. And I can use the word at for triangles as well, or for circles. Now, in the case of a triangle, it's a problem because you've got 3 points. And I use a structure for that. A circle only has 1 parameter, the radius, so it's on stack. So to generalize and say everything should be structures is not right, and that everything should be in a stack is not right either. You have to be flexible.
What are your thoughts on objects having a variety of methods?
I created an object in fourth called the month. And this object had the starting point in the year and the number of days or something like that. This was back very early. That's the only object I've ever done. And it was useless. I have much better ways of doing months now. So I think object-oriented programming is a mistake. There are not enough instances of the object to make worth the generalization.
Interesting. Thank you for your thoughts on that. Appreciate it.
That's why they call it oops.
Right, nice. Okay, Francis, please ask your questions.
Hi, Chuck. Can you hear me? Yes.
Okay. Hi, Chuck. It's an honor to speak with you, following for a while. And I just wanted to thank you for this gift to us. I was wondering if you could speak a little bit about the motivations for the circuit simulation software you wrote, its performance, and its current status.
Say again?
So I was wondering if you could speak a little bit about your motivations for the circuit simulation software you used to do the layout and electrical simulations, its performance, and its current status.
Yeah, that is one of my favorite applications. It's one of the things that I've spent most time on, and I think I've done the best job of. There's two aspects to it. One is the circuit logic description, and the other is a layout. If you are laying out a circuit board, or whether you're laying out a chip, basically the same problem with different geometries. And what I have learned to do is, in both cases, I do the layout. And from the layout, I derive the circuit, an array of transistors and interconnects.
Okay.
It's extremely efficient, extremely intuitive, pretty simple to implement, and gives wonderfully complete results. I've done a lot of circuit boards, but I've done even more chips. And the chip layout, well, conventionally one has a logic description of gates that are interconnected, and then from that you derive the layout. And I do it the other way. The layout is predominant, and the function of the layout is determined from it.
Yeah.
This is a strange side effect in that there is no need to do a validation proving that the layout accurately reflects the circuit. The layout is the circuit and is by definition correct.
Amazing.
And it's a lot of fun. I enjoy working with rectangles and layouts.
Yeah.
Unfortunately, again, just like the world doesn't let you interface with chips or boards or GPUs, the world doesn't let you interface with chips any longer. You have to give it a GDS approved layout, which they will then validate before they construct a layout which vaguely resembles the one that you worked from. It's a frustrating technological development.
Yeah.
I would love to have a chip making machine, something that will generate a prototype chip in a desktop environment. But the world is going to, the world prefers to have billion-dollar fabs.
Yep, yep. Yeah, I asked that because I was in my daily job. I do this as a maker and a hobbyist on the side. But in my daily job, I do chip design and process development for one of the big semiconductor companies, and this is a cool interest of mine. I thought I would ask about that. Just another question. What are the most interesting one or two applications you've seen in Forth from others that you didn't see coming?
The applications that Forthink does. And you can go to their website for a list. But they've done communication networks, device handlers, I did a Hollywood robot once, robot camera. Cement making plants. I would love to see an full self-driving car in fourth.
Yeah.
That's a heavy thing, though. As soon as you get into applications that risk human lives, it's a whole new game, and I've never done one of those.
And just a last question. In hindsight, is there any things you would have done differently with regards to fourth and setting it up, developing it, all that? Looking back after all these years.
No, in hindsight, I don't know that I've done particularly well, but I don't know that there's anything I would have or could have done differently. Back in what, 1970 or so, fourth, in a sense, was competing with Microsoft. Not directly, but conceptually. And if we at Fourth Inc. had developed an operating system, we could have competed with Microsoft. But we didn't, we couldn't. And I'm perhaps glad we didn't. I'm much happier with where we are now than where Microsoft is now. Microsoft has to be compatible, with the exception maybe of Windows 11, with everything they have ever done before.
Yeah.
And that is a horrible burden to bear. Fourth, as it stands, well, Fourth is free to reinvent the wheel. And I think that is a marvelous concept. No one should ever be afraid to reinvent the wheel. And we do it every day.
Thank you, Chuck. Thank you.
Mm-hmm. Yeah, thanks. And Howard, your turn. And please open the mic.
Hi, Chuck. I've already had a turn at chatting to you, but one more question about one's complement. It used to be very popular a long time ago. The IP, Internet Protocol, uses a one's complement checksum, and it has some interesting properties. I have a feeling that it's a really good way to go, and I observe that you use one's complement in Colorforth. And I just want to hear your opinion. Do you think that the world went wrong when it moved over to two's complement?
No, I worried about this. One of the mainframes I programmed early on was one's complement arithmetic. But two's is much more convenient, and it doesn't cost anything in hardware. So two's complement is definitely the way to go.
Yeah, I can understand that point of view. The thing I like about one's complement is that you've got this extra state in the system. In normal two's complements, you've got 0 and you've got everything else. And in one's complement, you've got +0 and -0. And it strikes me that it's very useful to have this extra state that can be used, so you can have a value is either 0, not 0, or not set, or some such. And I think this whole idea of having 3 states in a value rather than 2, it brings it closer to the optimal number of symbols required to transmit data, which I believe is E. Somebody proved a long time ago. So it's closer to 3 than 2. Anyway, it's just I think it's a kind of
Hamming
a cool
code.
idea.
You're talking about Hamming code.
Yeah.
Yes. Into discussion on computer file about that 2 days ago.
All right.
About Hamming codes and the transition of following the edges of the square to get to that.
Okay, thanks for the link. I'll look into that.
Yeah.
Okay, thanks, Chuck.
Okay. Right. So, Bob, you raised your hand.
Hello, I'm raising my other hand. Okay, I have a few. One thing I'm wondering, when I heard you programmed a mainframe that was one's complement. What mainframe was that? Do you remember?
That's why I didn't name it.
Okay.
Could it have been a Sperry Univac?
No, it might have been the
Dionysus?
Was it when you developed the rugs?
The first supercomputer. I can't come up with the name of it.
Right?
Oh, Cray?
Burroughs?
Cray, that's it.
Oh, okay.
Cray, or maybe one of its input terminals, something like that.
Okay, cool. Second question. You mentioned compatibility, and how Microsoft has maintained compatibility. And then, of course, you just mentioned mainframes. I was thinking ZVM, which is the current version of OSMBS, which is OSMBT, which is OS 360, has maintained compatibility across since the 1960s when it first started. And evidently, you can compile a program today on CVM, ZOS mainframe, and it'll run. And it just, it was interesting that you'd mentioned compatibility. IBM has had to maintain that for all these years.
Compatibility guarantees there won't be any progress.
Yes. What is the smallest fourth you've run across? What's the, what's the minimum, like, if you could, I don't know exactly how you quantify it, but like the smallest amount of memory, smallest amount of stack space, what is that? What would that be?
The smallest one I've done was called CM fourth for the Novix, I think it was. At Fourth Inc., we had Micro Fourth and Mini Fourth, which explored the range of having a small kernel and everything else compiled. E-Force does that, I believe. But I've heard references to some microcomputer fourths that had very small kernels.
Mm-hmm.
I would say a kernel should not be more than 4K. If you get it down to 1K, that would be nice.
Okay, cool. You mentioned in talking to, I forget who it was, but you mentioned that the 2 parameter stack, but you mentioned a stack that's only 8 feet. Is that for like as many levels as deep as you go, or is it 8? I bet would thought 8 was awfully small.
I would think in terms of a circular stack with 8 elements, so that you could put as many things on the stack as you want, but you only have access to 8 of them. Now, for the my circuit tracing algorithms, I've needed to stack thousands deep, because as you trace a circuit, you're recursing and recursing and recursing.
Mm-hmm.
And that's a whole different concept that I would have a software stack for.
Okay.
The hardware stack can be very small. 4 is too small, 8 is small, 16 is plenty.
Okay, cool. Two more. One is, did you know that the current .NET implementation of languages produce something called IL, and IL is a fourth light stack language? So they actually, you compile C into a fourth light language. I don't know if you've known that.
I would say no, because I haven't understood what you've said.
Oh, okay. Well, .NET is the kind of a, I'm sorry, Microsoft's answer to Java. C# is Microsoft's answer to Java. It's become very popular. It's actually a very nice language if you're writing that kind of software. But when it compiles down into something called intermediate language, which is actually a very fourth-like language. It's a stack-based language. I thought that was interesting. I didn't know if you had heard of that or not.
Well, all infix languages have to compile into a stack.
Mm-hmm.
So yeah.
But the interesting thing is this, it doesn't compile to a native. It compiles to IL. IL gets compiled to native.
An intermediate language.
Yeah.
Yes, that is, to me, that is grossly inefficient.
Yeah, why not write in intermediate language? And last thing is that you've talked about assembler and needing to know the x86 opcodes and such like that. In the 1130 assembler, you wrote an assembler. I mean, in 1134, you wrote an assembler so you could write 1130 instructions in a fourth light notation. Yep. I thought that was, I mean, it was right there, right at the beginning. It was very cool.
Not only 1130, all of my computers had assembly words.
Mm-hmm.
And I now think that was a waste of time. Oh. It was hard to figure out how to construct the words. It was hard to remember how they were constructed, and it was inefficient to implement. Yeah. The hex opcodes are, on any computer, are far the simplest way of implementing it.
It's interesting you're saying that, because it was just like, that was when we were looking at the code, that was one of the most intense parts of the code. Trying to understand what's he doing here, and then like saying, "Wow, that we thought brilliant." So, inefficient but brilliant.
It was fun. It was clever, but it was at least as difficult as the hex codes.
Yeah. Okay, that's it. I'm out of here. At least I'm going mute. Thank you for your time.
Okay, thanks, Bob. Our next questions come from Jan Bramkamp or Jan Bramkamp. I don't know.
If my microphone is working?
Yes.
Okay, so my question is, you've already ranted about infix notation and how it doesn't compose. What do you think about a prefix notation like Lisp?
I'm sorry, I lost my earpiece.
Sorry, let me repeat that. You've already given us your opinion on infix notation and how badly it composes. What's your opinion on prefix notation languages like Lisp?
They made an unfortunate choice. I believe the human brain works on postfix. You accept data, you store it in your short-term stack, and then you operate on it. You don't prefix things.
Okay, short answer. And are you satisfied with it?
Yes, I got my answer.
Okay. Okay, thanks, Jan. Next is Anton Ertel. Anton, please go ahead. Oh, maybe your mic volume has been turned down. So that's what happened to Gerald. So we can't hear you.
Mic selection, maybe answer.
No.
Do you hear
So
me now?
Anton,
Yeah,
mic-
no, and now not again. So
Yeah. No, I
yes.
didn't speak. So
Okay.
okay.
Go ahead.
All right. So the question is, what is your take on state smart words? I think you had them in your early fourth systems, and then you eliminated them. And I'm not sure if you have them in the recent systems. I don't think so. But can you talk a little bit about them? And yeah.
Yeah, I think maybe that's an area in which fourth has made some progress, or at least my fourth. And UHD fourth is basically color fourth. And different words have different colors. Now, state smart words would have different colors for different states. For instance, the color white means execute immediately. The color green means compile. And those are the only two states that I need. But I do have to be aware in programming. For instance, a conditional word like if or then is an immediate word and must be in white. If I have an if in green, it means compile a reference to if for future use. And that's basically what the state smart words did. You didn't have to be aware that they were, which state they were in. If they knew. But now I must be aware to distinguish green from white. And that is a programming challenge. Sometimes I get it wrong.
Thank you.
Yep.
Yeah, interesting. Yeah, Don, please.
Hello, Chuck again. How many items or how deep do you think we should build the return stack in our FPGA fourth? 32-bit fourth. That shouldn't matter.
I would go with 8.
8, okay.
I think the return stack and the data stack need not be the same length. But by default, I would make them the same length so that, until experience proved otherwise.
Would that be a circular stack? Sorry, can I just throw in, is that a circular stack that you're talking about?
It doesn't matter.
Okay.
We actually implemented circular stacks. So that was Dr. Ting. We shared the code with him. And he said, use circular stacks. I said, okay, so we did that. Dimitri implemented that.
It costs nothing in hardware.
My next question then to you is, why don't you utilize FPGAs? Because that is your desktop chip making scenario today. And I will offer you, when we get finished, I'll send you a complete system that you can play with. And it's going to be in System Verilog. And it's very beautiful code. Right now, it's like 2 pages of code to implement a fourth processor, basic. So why haven't you used FPGA for development?
Because they wouldn't let me program them in fourth.
There you go. That's great.
That's literally the reason and the only reason I would love to use an FPGA, but they won't let me. I'd have to learn someone else's ugly language.
Yeah. Remember, that's only maybe 5 years that there are open source tool chains for FPGA programming.
Thanks, Chuck.
Okay, Onat, you're raising your hand and you're putting it down and raising it. Maybe you have a question.
I actually wasn't putting it down, but
so please go ahead.
Sorry. Yeah, I have a question. I think like Forth is perceived as a runtime language, right? But it could be like a meta language. It could be like incredibly expressive and what are your thoughts about that? And also, I can ask the next question later.
So what exactly was your question?
Oh, sorry. So the question is, we're thinking about stacks and what stack to use and what kind of stack size to use, because that's the runtime Fort, right? That's the Fort where it's we execute a stack-based, we have a stack-based runtime, right? And that has a certain costs in terms of certain performance costs, and it doesn't actually map to architectures like GPUs, for example, because there is not even a concept of stacks. It's just you could have a memory stack on the GPUs, sure, but it's got to work on register. And I think Fort can be an amazing compiler. It's. I'm sorry. I'm super excited. So I'm somewhat inarticulate and can be harsh. Sorry.
Well, let me try to address that.
Yes.
Thank you. The stack is merely a tool that Forth uses to express things compactly. And certainly Forth has applications far beyond stack-oriented things. And yes, Forth would make an excellent compiler. Forth would make a good language translator. Forth would make a good artificial intelligence effect. And yes, I kind of agree. Forth is a meta language. It lets you define an application language suitable for your environment.
Yes, thank you. I mean, also that brings to the second question, which is I also think having the the 144 chip, in terms of the simplicity, that's the way to actually reach the energy consumption to the minimum, right?
Yep.
And do you think there could be other constructs other than the stack to or it could be I don't know. I was thinking maybe it could be a hardware definition language where we define those kinds of constructs for whatever problem at hand. So the hardware could morph depending on what kind of application it would run. We redefine the hardware sort of.
Mm-hmm.
You don't need to be. You don't want to think restricted to a stack. You don't have to use a stack for everything. As I said earlier, you can have structures which relieve the depth of the stack. And but the stack, I think, is at least a small stack, is absolutely essential for passing parameters.
Yes, I think I also come to that conclusion because it's super simple to pass parameters, and yet I think at some level it's all it could be even that we implement the whole compiler in assembly and use the sorry, I can I can ramble. But
Okay.
also, I just want to say, like, I thank you for all the inspiration and like for everything. I mean, I'm so happy that I briefly got to introduce you to some of the work that I've been doing. Which
Yeah.
yeah.
Okay.
Onat, thank you very much. I think we'll follow up on that later. Dimitri, another one.
Oh, it's a very short question. It was based on Don's question on the return stack, and in the chat, Peter Jacker, he was saying, well, you know, wouldn't the return stack need to be deeper if you're going to factor your code heavily? So Chuck, how could we have a return stack of say 8 deep and still factor our fourth code?
Oh, now
it's a question. It's a question of complexity. If you have too deep a call sequence, this calls that, calls that, calls that, it gets complicated and you lose track of what's going on. I rarely have more than 2 or 3 levels of nested calls, which is what the return stack is for.
I see. Okay, so it's quite flat. So yes, because you can still factor your application into lots of short words, but they're just not words that call one another in a chain. They all kind of stay at the same level.
That's right.
Oh,
The other
okay.
use of the return stack is to hold loop counts, although that's not the only way of doing it. So you want to consider how many nested loops you have, as well as how many nested calls.
Okay, that makes sense to me now. Thank you.
Okay, great. Thanks. So Jan for another question.
Yes, this time my question is regarding state smart words. I found them a pain in the posterior to work with. And wouldn't it be possibly easier to have an always compiling forth where interactive code is compiled into an anomalous function and executed afterward just to be immediately deallocated? Is there a downside to setting up a forth system like this, that it's always in compile mode and basically defining a word would only move the compile location from the scratch pad to the dictionary?
Yeah, I'm a little bit out of my depth because I don't know how state smart words are done conventionally. But I do agree there needs to be 2 distinct behaviors, one in which you're interpreting and one in which you're compiling.
But why do I need the interpreting state at all? Couldn't this be solved by compiling into a temporary scratch pad area large enough to hold a line of code or 2, then calling this code and reusing the scratch pad for the next interactive input? So always being in compile mode.
Yes, you could do that, and I think I did that once upon a time.
What is the downside?
It's no less clumsy. You still have to be aware of what you're doing. And it's just a different way. Well, say there's 3 ways of doing it. 1, you can have a state flag. 2, you can have different colors. Or 3, you could have this compile to scratch and execute. There's 3 ways of doing the same thing. I think the color way is latest.
So what I ran into with gforth or macrisp Stellaris is that, yes, there's a state variable and some words respond to it. And as soon as you want to do heavy metaprogramming and you need one of those state smart words in another state smart word, they don't nest.
That's right.
and at that point, you're scratching your head, and some forth systems work around it by providing non-state smart versions, and suddenly you have two or three times the number of words for those words that got for special treatment.
That's bad.
Yes.
I would rethink the problem.
Which is why I asked, because
I have a state smart state smart question for Chuck. So, you know, what I was thinking is you have a 32-bit wide fourth computer in an FPGA, but make the inside data bus 34 bits wide and then use the top 4 bits for your state, or whether it's an immediate word or you know, compile. I guess it's compiling and immediate. Is that the two things you need to figure out?
I have done that. One of the early computers that I had fabricated had 21-bit words, whereas the memory was only 20 bits. And that extra bit was used as a flag for various things.
Nice.
It was not good. It was as awkward and confusing and difficult as anything else.
Okay. Maybe I have a follow-up question and another one on that. You once talked about the ICE principle: interpret, compile, execute. And so if we enroll everything into just compile, don't we lose the interpretation capability to calculate things upfront before we compile? So do we need interpret, compile, execute, the ICE principle?
You're exactly right. We do need the ability to calculate things. And that's why in ColorForth, if I'm compiling green words, I can interpolate white words to do the calculation.
Yeah, so we don't want to lose this. And maybe Jan, this also answers a little bit of that. We don't want to lose the capability to do execution while we compile and calculate things and generate code or whatever.
Right.
I didn't propose to eliminate immediate words.
Anyway, my second question. You've been once talking about the map is not the territory. And I would like to hear your current opinion on the statement and how you think about abstraction.
Oof.
So
The map is not the territory. But currently I prefer to work in the territory. No, that's not accurate either. In the case of drawing characters, you can either draw the character or you can describe the character. And a long time ago, I would draw the characters. And that became a pain because I would somehow move a pixel the wrong place. Now I describe the character. And I've come up with, I think, a very compact way of describing characters. So I go back and forth between the map and the territory.
I see. Yeah, thank you very much. And thank you very much for influencing my life over the last 40 years. Sure. Yeah. Yeah, maybe without knowing it, but you did.
It's a responsibility.
Yep. Right. Next question comes from Travis. And you have to unmute so that we can hear you.
About 8 deep return stacks. I found a number of different uses for return stacks. Like, for instance, I'll make a word. I have a word that allots space in the dictionary, and then deallots it afterwards. And I'll use the return stack as scratch space for storing the top of the here pointer before and afterwards, so I can restore it and return it, including if an exception occurs, I'll catch the exception, restore the dictionary, then rethrow the exception. And also in my fourth, I have to do with exception frames, which go on the return stack. And furthermore, there can be nested exception frames where one exception is within another. So and furthermore, the multitasking uses the return stack. So to store registers and all that. So in essence, I need far more than 8 cells on the return stack to store all of the possible states, even if my code itself does not go that deep. So what are your thoughts on this?
I understand. You can have a large multi-purpose return stack, certainly. My concern is that it's getting complicated. And I tend not to like it being complicated. I would observe that in the case of circular stacks, when you get an exception, you don't need to do anything to the stacks. You just leave them where they are and get on with the business, because you don't need to keep them clean. So yeah, I think the simplest solution is to have a small return stack. But I understand the convenience of having a large return stack.
Mm-hmm.
Thank you.
Okay, we have 2 other guys that want to ask questions. John Hardy, please.
So me again. I was just, I mean, this return stack's an interesting topic because it is necessary to discuss all sorts of different aspects of forth because the return stack is so critical to the virtual machine. I'm interested in the changes that happened in Colorforth. Some of them have to do with your use of tail call optimization as a way of reducing. So in other words, optimizing away calls so they become jumps, which means that they use less stack space. So I can see that would reduce the size of a return stack. But one thing that seemed to get thrown away from my understanding of classic forth is that you use tail call optimization as a looping mechanism, and that in classic forth, when you redefine a word, or when you define a word, you don't have access to that word. It's hidden until you're finished defining it. Whereas in Colorforth, I believe the word is visible so that you can call it, so it can be called by itself. So can you talk a little bit about that change in the language, and like what are your thoughts about the way, ditching the idea of the original forth and going forward in this way?
Yeah, the original way would be my preference, that you rarely reference a word within itself. More likely you want to redefine the word, add some functionality to its previous definition. But that was complicated and awkward. And in color forth, I just threw it away and said, okay, I'll have to live with the fact that if I want to redefine the name of a word, I'll have to say word, word, word zero, word zero, stuff. That's awkward, but it doesn't happen very often.
Yeah.
Actually, I found that in my forth that doing it the way that you did it before, it's simply a matter of linking the word that you're compiling into the dictionary after you hit the semicolon at the end. And it works basically like how it was where if you redefine a word, you refer to its old meaning from within the new word without any work at all.
Yes, that is exactly right. But in my current forths, semicolon does not indicate end of word. It merely indicates return from word.
Return, yeah.
Mm-hmm.
And so I have no word that identify the end of a word.
Mm-hmm. Okay. John, another question or?
No, that's it, actually.
You're done.
Fine,
Thank you very much.
I'm
so,
done. Thank you.
No, satisfied. Okay, the last question for today comes from James Norris.
I was wondering what the most fun thing you ever worked on was.
Most fun thing. A fun thing is something that gives you frequent positive feedback. I have to say my chip layout and simulation, it took years, 5 years, but I was immediately doing good work after 1 week. So I got this positive feedback, which continued and continued and continued. The hard part of that was when you submit a chip for fabrication, and you have to wait 3 months before you know whether it worked or not. And what do you do during those 3 months? But I have to say that was a lot of fun for a lot of years.
Mm-hmm.
Chuck, this is Greg asking another question. The trip simulation is fantastic. I think one of your very first projects that you ever worked on was the telescopic pointing and the data analysis you did interactively on the system with all the other astronomers watching the work output, because that is quite significant to use something as large as a radio telescope to capture the data live and to manipulate the data to generate those graphs. That I think ought to be significant.
It was at the time. There was this millimeter radio telescope was being used to discover interstellar molecules.
Wow. Okay.
And you would collect data and display it. And if there was a peak where you expected a peak, you discovered a molecule.
Right.
And the immediate feedback was very useful for the astronomers. But they still required that I record the raw data so they could take it home and repeat the analysis, even though that was completely unnecessary.
Brilliant.
Mm-hmm.
You've done the processing already.
Yeah.
Mm-hmm.
And they were going to redo it, probably not as well, because I had good statistics.
Live statistics, forget about post statistics.
Well, guys, I see we had a fantastic meeting today. We need to thank 1,000 times to Chuck. But there are people in the meeting. I see Rob Jude from Australia. Do you want to say hello and anything to Chuck? Not questions, but only hi.
Okay, hi, Chuck.
Or do you have questions? Sorry. No questions. Okay. Who else? I see Ray Gardiner, also from Australia, very late in the night. Ray. Ray showed us in the group, in the Facebook group, fantastic pictures of his boards with the RTX 2000 and image vision in Australia for machines, for different machines. So he's a wonderful folder and incredible stuff. I see in the meeting, Ashley Faniello wanted to show us the wonderful Fignition. Do you want to say anything, Ashley? Something to Chuck?
Oh, just hello, Chuck. We met once in 2013 at the Strange Loop conference, but it's great to see you again. It's always great to hear what you have to say.
Who else? I see Ilya Tarasov from Moscow. He's chatting, but he does not like to talk. What happens, Ilya? Too much vodka today? Say hello to Chuck.
Okay, I'm here, but I'm afraid with my new microphone, it will be not possible to hear me. Okay.
It's very good. It's very good.
I just want to say hello. No more. What else?
Hello.
What else? And wish everyone to be healthy.
Thank you to you too.
3:30 in the morning in Australia.
It's
Wow.
Indeed, this is a word-by-word translation of Russian hello. Be healthy. Yeah.
Wonderful. Thank you, Ilya. I see also Jonas Carlson. Where are you in the world, Jonas? Do you want to say hello to Chuck? You are muted.
Oh, yeah, one moment. Yes, so yeah, I'm in Bangkok at the moment. And well, at the moment, we're all stuck where we are, right? So it's 2 years. So I had time to play with a lot of things. And the last thing I played with a few months ago was a 6502 fourth. And I was reading in parallel a lot of things about color fourth. And I found similarities when I was basically creating a system with an online editor running on a 6502, where each page, 256 byte, was maybe buffer size basically, and this fourth was a byte coded fourth. Actually, it's an alphabetical byte coded fourth. So I use D for dupe, and I use S for swap, and so on. And of course, the arithmetic operations are plus. And I remember reading when I was working on this, that you actually liked the idea of a byte-coded fourth, but you never really went to do that. Do you have any comments about that? And especially about the code bloat today, we have so big systems and they're compiled to yield hundreds of bytes. Yeah, so that's my general question. If Chuck is there.
Yes, I've thought about byte coding. Other people have also. It's a good strategy. The closest I've come to it is the GA144 instruction codes. They are 5 bits. So I've effectively done byte coding on the hardware.
Right.
ARM microcontrollers with ARM v7m have the TBH and THH instruction, which are basically what you're asking for, bytecode jump tables in mass manufactured CPUs, which can be used
Yeah.
for bytecoded forth with a very tiny interpreter.
Yeah, I'm finally building my so-called alphabetical fourth, which is supposedly half readable kind of bytecode with letters and symbols. And I'm writing a very tiny C compiler that compiles C to this fourth, and I have it kind of working for functional C with no variables. And just the other day I added variables, so soon I will be able to compile C to fourth. And the rationale for this is ESP32, which I calculated that, yes, it's a very powerful thing, but one line of C code usually ends up being about 80 bytes of machine
Fantastic,
code.
Jonas. We are saying
Which is
bye-bye,
great.
bye-bye.
Yeah.
We are finishing. Bye-bye. Thank you.
Great.
Another one here. Holy Nepu. Is this correct?
This is Holy, yeah, from Taiwan.
Holy, how are
yeah.
you?
No,
From Taiwan.
you invite us to join this join this meeting. Actually, I want to say that I've developed the cross compiler for different micros MCUs, and the cross compiler include assembler, disassembler, and compiler and cross compiler. One special trick is that once the assembler is generated, the disassembler is automatically generated. And the assembler that I designed is based on algebraic assembler. So every microcontroller can be seen the same because I use the same instruction like register and immediate word. You can see that all microcontroller can be seen as a fourth chip, not the really fourth chip, but actually, if we say it is fourth chip, and it contains only register and immediate word. So that way, based on these two words, two characters, I can design the assembler based on these two. So every microcontroller seems the same, and the assembler has. I can design the assembler in different way.
Fantastic. This is great news. So we love to hear from you, and we send all our regards to the fantastic FIC Taiwan and all the great members you have. Also in the name of Dr. Ting, who is here, and he wanted to show something, but we will do this in the next meeting because we are out of time. Thank you, Holly, for participating.
Looking forward to hearing more about that at a later time.
Okay.
Yeah.
If you are interested.
Another friend here is Igor Matsnitsa from Estonia. Is this correct, the name, Igor?
Yes, do you hear me?
Only to say hello to Chuck and wish him well and etc. But
do you hear me? Yes.
Yeah, but the mic is not making noise, but it will do.
Hello, Chuck. Thank you very much for your creation. And I met Ford first time in my school, and it made a big movement in my development as programmer. Thank you very much one more time, and be healthy in this time. And I wish you many years and a lot of implement your plans.
Thank you, Igor. Karsten, do you want to say hi to Chuck and bye-bye? Where are you from, Karsten? From Germany? I cannot. Carsten, yeah. Your microphone. I cannot.
Maybe you have to put on the volume, increase the volume, Carsten.
But okay,
then
no
just
problem.
wave into the camera next time. So
Yeah.
Carsten is from Hamburg, actually.
Oh,
just,
cool.
Across the city. And yeah.
Thank you very much, Carsten, for participating. Next time we talk with you. Rolf, also from Germany. Do you want to say bye-bye to Chuck and thanks, etc.? Or Rolf has no microphone. Who else? I have.
What's going on? You're muted, Ralph.
Hello, Jack. I want to say hello from Germany, Bielefeld. And I was motivated to write my own force, my own tiny force, because everybody should write its own tiny force before using a professional force, I think. And I learned it from you.
I see also Thomas Goeppel from Germany. He helped us putting the link in the Hackaday. So I thank you very much to Thomas. And he's also a great participant here in our meetings. No sound, Thomas.
Hello?
Yeah.
Thank you, then. If you have no sound, thank you again. Who else? Atle from Norway. Do you want to say bye-bye and thank you to Charles?
I'm a relative newbie in Fort, and I just want to say thank you, and I find it brilliant.
Thank you. Anthony Fogeler, do you want to say bye-bye and thanks to Chuck?
Yes, I say hello to Chuck, and thank you so much for all the difficult nights I have to work through to find bugs in my programs Forth related. It was very enjoyable. And still today, 2 months ago, I started a new project with Forth, so it is still very alive for me. Thank you.
Well, who else? Jorge from Brazil. Jorge Janaite, do you want to say?
Oh, hi. Are you listening?
Yes.
Yeah.
Oh, hello. I'm Jorge Janaite from Brazil. I'd like to say thank you, everyone, especially Peter for organizing this event, Chuck for discover, like he says, this incredible language. It's amazing. It's more than a language. It's a philosophy. The fourth way to think. I don't know. I really love this. It's a pleasure to talk about Forth with people who likes Forth. It's thanks Peter, Ulrich, John Hard, Chuck, Dr. Ting, everyone. It's really nice to stay with them today.
Thank you for your love in the language, George. You are a great father. I have also here Thomas from Köln. Thomas,
Yeah.
Fabula.
Thank you. Can you hear me? Thank you, Chuck. Thank you, everybody, for this very marvelous meeting. And I was using Force began in I think 85 to 87. Wrote my my thesis in physics. It was a great time. So thank you all and have a good time, Chuck. See you soon. Bye-bye.
Thank you, Thomas. Pablo de Argentina. Pablo Reda.
Hi, I like to say thank you to Chuck Moore. I am a color for fan. I learning Ford, reading the color for source, and I changed my life with this marvelous language. Thank you.
Thank you, Pablo. Who else? Somebody else? And then we close. Cecil Bayona, I don't know, Philip, Eli.
Yeah, it's a pleasure. So Chuck, again, many thanks for the inspiration you gave me during those years when I was a student and still now. And clearly you are a wonderful person. So thank you for everything.
Fantastic.
And thanks again, Chuck, for being here. I've been following Forth for many years. And in my youth, when I first heard about Forth, I was so excited. Somebody who wanted to keep things simple rather than the abortions we had for programming at the time. So thanks again for your great idea. And what can I say? Thank you again.
Well, guys, this was fantastic. I don't know if Chuck agrees to that, and we do all these meetings thanking and thanking everybody in the Forth community, all people from SVFIC also who helped us every meeting, and from all the communities in the world. Howard, do you have a raising hand?
Yeah. Chuck, is there any chance I could get my hands on your clock code? I'd like to put it in as an app in Colorforth. Do you have any plans to post it anywhere?
I don't have a vehicle for posting things.
Can you send it by email?
I could send screen captures, maybe. I'll keep it in mind.
Okay, I'd also like to see the source for your character generator code. That interests me.
That I would gladly publish. Again, if I had some way of doing it. I used to have the website. I keep thinking maybe I should reactivate the website, but I haven't yet.
Okay, if you come up with any way of transferring it and I can help in any way, let me know and I'll help you gladly.
Okay, Howard.
Cheers.
I want to thank you all for inviting me. It's been fun, and it's gratifying to see so many interested Forth people. I wish you all well in your endeavors.
Thank you.
Thank you.
Thank you very much.
Yeah.
Thank you. Thank you very much for joining us.
Thank you.
Thank you, Chuck. Thank you, everybody.
Thanks, Chuck.
Thank you.
Thank you, guys.
Save the chat.
Forth is alive and well and kicking. It's going to be the dominant language of the future. Don't worry about it. We got this, Chuck.
Really appreciate your insights and influence. It's been great. And I wish you great health and good tidings.
Yes, I agree. Thank you very much, Chuck.
So bye-bye, friends.
Thanks, Peter.
Chuck,
Thank you.
This is all Forth, Chuck. This is all like written in Forth and generated into like GPU code somehow. And like, I mean, this is I would love to actually like demo this.
Oops, he dropped out. I don't know. All right. So yeah, I think that concludes our meeting today. Thank you very much for joining us all.
Thanks for the invitation, the organization, to everybody.
Yeah.
Have a good evening,
Yes.
night, or
Thank
morning,
you.
wherever you are.
Thank you so much.
Okay.
Thank you.
Okay.
Bye-bye.
Bye-bye.
Bye. Bye.
Bye.
Goodbye.
Bye.
Cheers all. Okay, bye.
Bye.
Bye all.
Okay, I'm stopping the recording right now.